Hello, hello, hello. Welcome, everybody. Welcome to the stream. Hello, welcome. Hello, hello. Today, we have a very, very exciting journal club to talk about. I have not had quite as much fun putting together a journal club as this one in a really long time. Like, I had an absolute blast doing the research for this one, and I think you're all gonna really like this. If you couldn't tell, nuance is the name of the game today, and if you showed up to stream expecting a very simple, is aspartame good for you, is it bad for you, does it do anything, you will leave disappointed. But in return, I will say that I think investigating the nuances is part of what makes, I think, my channel fun to be around, just because, you know, sometimes reality is complicated, but sometimes the complications are by themselves interesting. So let's get right into it. I'll just start off by saying hello. Hello, Park. Welcome. Hello, Robert. Good evening. Hello, James. Welcome, welcome. I think I already said Robert. Yeah, hello, Robert. Clockwork. Welcome, welcome. Sorry about your rig. Hello, Archie. Welcome, welcome. Hello, Neutrophil Mapping. Welcome. And Flying Taco. Hello. Otto, welcome, welcome. CR Smith, hello, more juice, welcome. All right, so let us just get right the heck into it. I'm really excited to have this conversation, and if you want to follow along with the paper is linked in the video description. Okay, so not only is there nuance, I also, of course, have to make this disclaimer. I am not a doctor. Nothing in here is medical advice, just analyzing the conclusions of a science paper, which I am capable of doing. So the paper linked is not a clinical trial. That's immediately something that should be said out loud. This is a study done in model organisms, which puts it into my ballpark. So do not extrapolate any of this as official medical advice. We are simply analyzing this paper on its scientific merit and determining whether or not that has clinical relevance down the line. All right. And I think what makes journal clubs like this so special is, unlike a lot of debunking YouTubers who will do the research for you, I will actually show you the data. And I think it's more interesting to see the ways in which that this paper is written in order to get the full effect of the kind of controversy, right? Because hearing the controversy summarized doesn't hit quite the same as seeing the data and the words that are used with your own eyes. So, all right, let's get right into it. Pfizer aspartame in that can or not? Tell me. Maybe I'll reveal at the end of stream what I've been sipping on this entire time. Okay, so the first thing to note of this paper, this is the paper in question. So this paper got a lot of press on Reddit, a lot of backlash on Reddit. Redditors were very angry about this paper and about its supposed conclusions. And so the first thing to note is that there are two aspects that I want to pay attention to. One is the actual title. Sweetener aspartame aggravates arteriosclerosis through insulin-triggered inflammation. Okay, and the second thing that I want to point out is the fact that this is published in Cell. So the reason why I'm saying that this is important is because when a paper is published in the big three, Nature, Science, or Cell, you kind of have to pay attention, right? Like, I'm not saying that these journals are not capable of publishing crap, but I will say that if it is published in one of these journals, you should take extra care. You should be extra careful with criticizing the paper, because maybe there's an aspect that you're just not seeing, and you really have to be extremely careful, because you can come off as arrogant or you know, whatever, if you criticize this wrongly, right? Like, you actually have to like double check and be very careful. So that's why I want to start off by saying this is not like a no-name paper in a no-name journal that is controversial. This is published in one of the best journals for biology, so there is a level of expectation for the quality of this paper. So that's a little bit of the context. I wanted to take a look at some Reddit comments just to give you an idea of why I really wanted to cover this paper, because the reaction by the Reddit community was so intriguing that I had to read the paper for myself. I'll just read the comments out loud. To quote one of the critiques, however, it is unlikely to be of direct relevance to humans. This study was done in mice that were genetically engineered to lack a key lipid transporter, then fed a high-fat diet to stimulate the formation of fatty plaques in their blood vessels. And then a response to that, well, the heck is the point then? It's like saying you can get rid of cancer in vitro by pouring bleach on the sample. Okay, that's that's pretty mean, I would say. It's pretty mean. Another commenter saying, we genetically engineered mice to respond horribly to aspartame. When we fed them aspartame, they responded horribly. Again, pretty snarky comments. And then another paper just says it. Another useless paper that will only be used to fearmonger. Maybe post randomized controlled trials instead. So a lot of these comments were of this flavor. In fact, I could not find a single comment under this thread defending the merits of the paper, or even pointing out that there are any merits to this paper. It was just one big Reddit hate fest. Here are some more comments. Humans aren't mice. There you go. Not only are humans not mice, but they literally use genetically modified mice, which massively exacerbates the problem. Also worth noting that this is a similar situation to the oldest studies of artificial sweeteners, where that gave rise to the rumor that they cause cancer. If memory serves, the researchers, aka paid misinformants, used breeding lines of mice that were disproportionately prone to cancer for the test group. Okay, so a lot of people unhappy about how the research was done, and I wanted to see, by reading it for myself, to actually figure out if what any of these Reddit comments were saying had any kind of merit. So I want to do this through a couple of different steps just to give you an idea of how I walk through a paper, and we will look at the data together to come to our own or your individual conclusions. I'll give you my thoughts, obviously, but what I believe might not be the same as what you believe. So I believe you can make up your own mind when I show you the data, but it will be filtered through my lens, right? Because I am picking and choosing to frame the data in certain ways. So I do want to admit that there's some level of bias there, but I will show you their data as they have published. Okay, so the steps that I take when it comes to analyzing a paper that has a lot of emotional weight to it, like a paper that gets people angry, I take a couple of extra steps when reading it. And the first extra step that I take is to acknowledge one's background and bias, right? I don't really, when I read for work, I'm not thinking like I'm a neurobiologist, so therefore I have a certain lens. I just read the paper. But when it's extra spicy, I take extra care to acknowledge my own shortcomings. I go through a process by which I read their introduction and I try to assess whether or not I believe the problem they are trying to research is actually worth throwing taxpayer dollars into. I analyze what the research question really is. I analyze how the research was done. I take a look at what the results are, and then I take a look at what the conclusions are. So results and conclusions are different, and we'll talk about why they're different and how they're different. And then this is what's really important, and this is something that I really want to thank my graduate advisor for instilling in me, is that even if this paper is absolute dog water, the mentality that you should have when you are reading science is not whether or not I trust this paper, but what is the minimum unit of information that I can trust? Like, what can I take away? What is the minimum amount of information that is true here? Because you should not be throwing out studies just blanket, right? You shouldn't just be ignoring things because you don't agree with the way that things were done. Try to see if there's anything in the paper that can contribute to your knowledge. And I think that's a very helpful mentality to have. Okay, so I would like to do this exercise together. You don't have to like reflect in chat, but I think it would be fun just to do the exercise like I would in a classroom if I were teaching a class that's based on paper reading, to do this, because I think that it is important to acknowledge that we have fault, right, and limitation. So I'll go first. So I have a graduate degree in molecular biology with a focus in neurobiology. My model organism was primary mouse neurons. So I have a very basic understanding of mouse biology, breeding habits, rough age of maturity. I'm passingly familiar with the kind of health issues my particular mouse line has, but I would not say that I'm a mouse biologist, right? Like the model system that I use, the tool that I use is the mouse, but I'm not intimately familiar with how the mouse works. I'm familiar with molecular methods, general research methods, right? Like I'm pretty confident in my own ability to teach myself anything new in the field of molecular biology. But I am unfamiliar with the particulars of metabolism or heart disease, right? Like I studied the brain, and so while there are overlaps with metabolism, I have like no overlap with heart disease at all. So I am stating right off the bat that this paper that is about metabolism and about heart disease, I don't have any expertise in either one of those. But I don't feel like I need that expertise to get something from the paper, right? Like I want to learn from the paper and I don't really need all of the background to learn everything. Or sorry, I should say that I can still learn stuff without the appropriate background, right? I think that is fair to say. I might not understand everything, but I can understand enough where I can form an opinion, I would say. Okay. In terms of background, I am a biology instructor. So my job is to help students with figuring out biology. And I have one bias, which is I am against reactionary Reddit r science commenters. Nothing makes me more intrigued, I would say, or more curious as to when Reddit is freaking out about a paper. And a lot of the times they are missing the nuance, which is why I started the presentation with the big slide that says nuance. Like they're very reductive in the comments section, which is sometimes annoying. Sometimes it like is very frustrating how they flattened a lot of research, which is why, you know, it's fun for me to be able to like dig into it here. And finally, my bias with regards to the actual information is that I am a water and light seltzer enjoyer. In terms of artificial sweetener, I have an incidental amount of consumption through some protein powder that I really like. Instead of like a milky protein powder, it's like a juicy cut and milky powder, protein powder, and it is artificially sweetened. So I don't really care as much. Like I'm not like a Diet Coke a day kind of person, so I'm not that emotionally invested if I have to switch off my protein powder. So I'll say that out loud, right? Okay, so those are my backgrounds and biases, and I will give chat a little bit of time to think about what your biases are and backgrounds are while I catch up on chat. Should we get Sideray to look into the psychology of Reddit hate comments? Actually, no, let's save for sanity. I mean, Sideray's field of study is actually probably more insane than the psychology of Reddit hate comments. I'm gonna be real. I love Reddit salt. I wanted to say as much. That's a perfect way of putting it. How much umami does it have? It's so addicting. Once you start popping Reddit salt comments, you just kind of can't stop, right? Like, and it's so rare that I get to do it in a paper of my own field, right? Because this paper, I would say, is comfortably in my research, not area, because I didn't study heart or metabolism, but like I'm familiar with the language of the research, whereas a lot of the Reddit salt comments comes from like psychology papers or sociology papers and stuff like that. Like but whenever you get like a diet thing, people get all mad, or a vaping thing, people get really mad, and then there I'm like, oh, I can actually like I can sample the salt myself. So in like analyzing your own bias, it looks like we're kind of split in terms of like artificially sweetened good here's with 31 total votes, which is really surprising. So about half of you have some kind of stake in the outcome of this paper, I would say, which is interesting and important to note. Does aspartame cause an insulin spike or response in human systems? Is a taste of sweetness enough to start the machinery before the actual metabolite hits the gut? Ooh, we will talk about that. I have ADHD, too long didn't read. Does it cause heart disease or no? I will not give you the answer right now because there's a lot because it's not an easy answer. It's just not an easy answer. What I will say is that aspartame is very heavily studied and generally recognized as safe, and I think that is uncontroversial to say. But this is a new paper. It dropped like last Wednesday or something, so I had to pull this presentation together very, very quickly. Is it G-subs fly? Not until they give me money. The Redditor hater, that's me. All these cool science backgrounds, and I'm like, I'm a liberal arts major, history, and I'm passingly familiar with this stuff with what I've learned on YouTube. Everybody's research area is cool. I mean, it wouldn't be your research area unless it was cool, right? Everything is cool to somebody. I'm sure like, studying artificial sweeteners is boring for a lot of people too, but I'm glad that I have a little community here that appreciates getting way deep into a biology topic. For sweeteners, I eat fruits, but I'm not scared to eat sweets from time to time. Yeah, that makes sense. I would argue whether or not you answer yes or no, you have a stake and bias in this. Yeah, it's true. I've joined and this made me hungry. Yeah, I think I'm feasting on Reddit tears, or I would like to. I don't actually know. At this point, I think my relationship to the Reddit comments in this particular paper will be also interesting to analyze. So I think it's a pretty fun way to dive into the paper. Okay. So I've acknowledged my own background and bias. I am anti-Redditor. I am neutral on artificial sweeteners. And now let's take a look at the actual paper. So this is the introduction to the paper, and I will just read it out loud. So I have a very important part underlined, but we'll just read this together just to show you what the language is like. Artificial sweeteners, shortened to ASWs, are known as non-nutritive sweeteners, or NNSs. Biology is full of acronyms, so it's just going to have to get used to that. As alternatives to caloric sugar are much appreciated by consumers. Aspartame, APM, as one of the commonly used sweeteners, is approximately 200 times sweeter than sucrose, and its caloric value in added food and beverages is nearly zero. According to the FDA, the maximum recommended daily intake of aspartame is 40 milligrams per kilogram body weight in Europe and 50 milligrams per kilogram body weight in the United States. Unfortunately, unintentional aspartame consumptions by adults and children often exceed those recommended by the FDA authorities and are associated to various health complications. According to published reports, APM has been associated with various diseases, including obesity, type 2 diabetes, cancer, cardiovascular disease, allergies, neurological disorders, and behavioral disorders. However, the health impacts of aspartame consumption, particularly the consequences of its long-term consumption, warrant future in-depth investigation. So, my spidey senses started tingling as soon as I read this particular sentence underlined in red. Because remember, I'm anti-Redditor. So I have a natural bias that leads me to want to believe that the paper is smarter than the Redditor. That is my natural bias. But this claim, unintentional aspartame consumptions by adults and children often exceed those levels recommended by the FDA and are associated to various health complications. That is crazy to me. I just don't believe that. Like, I don't believe that I am unintentionally taking in a lot of aspartame, unintentionally drinking my Coke Zero right now. That's a crazy thing to say. So here's the thing. 2 and 4, there are 2 citations here. And of course, you know your boy clicked on those citations, right? So this is source 2. This is a review in a very controversial journal called MDPI. This is quite infamous for its questionable quality control. And so that doesn't mean that every paper that MDPI publishes is trash. It just means that your mileage may vary by a lot, put it that way. So it's a review in a sus journal, so I'm immediately suspicious, but like not everything they publish is crap, so you just gotta like read it to find out if it's crap. So here's the citation: aspartame, true or false? A narrative review of safety analysis of general use in products. I'm like, okay, cool. What do they say? So they have this huge review of aspartame and its role and everything. And since we are talking about metabolism and heart disease, I focused on mainly 2 parts, the obesity part and the diabetes part. And what I'd found is that if you read those sections, that the connection between aspartame and those conditions in humans is actually not that certain. And I didn't look at the rest of these because I just didn't have time. So what about this claim, right? So diabetes and obesity, the connection isn't that strong. Even that review says it's not that strong. So what about this claim? Like, we're accidentally drinking aspartame? Like, what the heck? Where does that come from? So I searched that review, and so this is what the cited source says. As many products contain aspartame, both children and adults can unintentionally consume larger amounts than those recommended by the FDA, which may lead to health complications. Source 7. So here's a very important word: can. Both children and adults can unintentionally consume larger amounts than those recommended by the FDA. As many products contain aspartame. And I'm like, okay, sure. Okay, I am open-minded. I am willing to believe that maybe we eat more aspartame than we intended to. For example, my protein powder, I didn't know that it was artificially sweetened. I just didn't bother to, it didn't taste super artificially sweetened to me. And so I was kind of surprised to learn that my protein powder was actually artificially sweetened. But like, I don't know, I drink water and I don't really eat a lot of candy anymore. So I don't know where they're like slipping this aspartame. So I see this citation 7, and I go to that citation, and what does that citation say? Oh, sorry, that's in the next slide. So I want to first contrast the language here. The citation says both children and adults can unintentionally consume larger amounts. And the paper in question says consumption by adults and children often exceed those levels recommended. And these are different claims. I can consume arsenic, but I try to avoid exactly more juice. It is, and C.R. Smith, can and often, a difference of one word changes the claim entirely. And I'm like, my like rhetoric background, I mean, you don't have to have a rhetoric background to realize this, but this is a very, very tricky, little dishonest, maybe a little more than dishonest. So I'm like, oh, that's crazy. And of course, nobody on Reddit caught this because only I'm like crazy enough to actually do something like a read the paper I'm criticizing, right? Like, this is very bad. And this is what my advisor would say, immediately turning your audience against you. Like from here on out, my spidey senses are like going crazy. Like I will not trust a single line from this paper because of an error like this. It is actually tragic that this happened. Yes, sus emoji toxo. Exactly. This is extremely suspicious. Okay, but let's check the cited source, right? The cited source says both children and adults can unintentionally consume. So maybe source 7 has some data that would say, hey, when we actually logged the food that the average American eats in a week, they overestimate or they underestimate how much aspartame they're consuming. So what is source 7? Rodent study. Source 7 is a rodent study. It is not a study done in humans. It has almost nothing to do with overconsumption of aspartame. And now I'm like, oh, this is bad. This is bad. I am stunned that this has been published in Cell at this point. Like, I am unhappy. And I'm showing you that I am unhappy, and you get to see why I'm unhappy, so you understand why I'm unhappy, right? Like this is, I want you to see for your own eyes, right? Oh no, the rodents were unintentionally ingesting aspartame? True, exactly. Dumb rats. So stupid, these rats. Can't believe you would accidentally eat aspartame. Plenty of non-sweet foods have sweeteners. Always check the labels. That's the thing, like, I was willing to buy that premise, right? I like, sure, maybe there are foods that I'm not aware of that have aspartame in them. I don't actually know any. And Morjuice, if you're right, then why not just cite those sources? Why put in a freaking rodent study as source 7? Like, this is sloppy work, right? I'm immediately suspicious. Okay, were the peer reviewers asleep at a wheel? Yeah, this is pretty egregious. Like, I'm already like, again, my bias is anti-Reddit, and I'm like, I'm kind of on Reddit's side for now, even though the Reddit, we'll see to what extent their comments actually are real. But I'm agreeing with the vibe that this is a bad paper, but I'm not agreeing with what they're saying yet because we haven't even gotten to the methods yet. Okay. Okay, so the next claim, according to published reports, APM has been associated with various disease, blah, 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 and then they cite 2, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I didn't like go through every single one of these, but another sign that they are just messy is that one of these citations is a Nature paper about glucose tolerance and the microbiome, but it's not about aspartame, right? This claim says aspartame has been associated with various diseases. One of these is a microbiome paper about saccharin. And I'm like, dude, bro, this is Cell. This is Cell, man. Every researcher's dream, every biologist's dream is to publish in Cell. And this is just like not acceptable. This is so sad. I'm so sad. This is like not cool, dude. And this could be fixed by, instead of doing APM, aspartame, artificial sweeteners. Saccharin counts as an artificial sweetener. Don't have APM here. That's an easy fix. You can still cite this paper, but why call it aspartame? This is a level of like, you have to be very careful when you write science. Like, this is sad. This is sad and depressing, and I'm sad. And this makes me sad. But okay. Let's continue reading the introduction. Accumulating preclinical and clinical studies suggest that artificial sweetener consumption is a potential risk for cardiovascular disease by investigating factors such as hypertension, vascular dysfunction, inflammation, weight gain, and gut microbiota perturbation. However, a couple of studies show no adverse effect on body weight, or a couple of studies. It's more like a ton of studies, but okay, a couple of studies. We all have different definitions of how many studies are. I'm such an ass. I'm so whatever. A recent prospective large cohort study based on 100,000 human participants suggests a potential direct link between artificial sweetener consumption, especially aspartame, and then these other ones, and high risks of cardiovascular disease. Okay. Suggests a potential direct link is an oxymoron, right? Suggests a potential direct link. What you're saying is correlation. A correlation is a potential direct link, right? Like if it's either a direct link or it's not a direct link. It's either a direct link or it's a correlation, right? It's pretty hard to say suggests a potential direct link. Just like this makes me feel bad. And this is why it's so important to learn how to write in a good scientific way, because if I'm reviewer 2, I'm like fuming already. Like I'm saying no, because it's not careful. It's messy. Thus, most of the published data generally support the participation of artificial sweetener consumption causing cardiovascular disease. I don't know if that's true. Again, this is why I've acknowledged my bias, right? Like, or my background. I'm not like a metabolic person, but the general consensus of the public and of a lot of like professional health communication is that artificial sweeteners are generally considered as safe, right? So if you are making a claim contrary to that generally held belief, you have to do a little more legroom. That's just a part of paradigm shifting, right? Like if you want to shift the paradigm of a minority claim, which happens all the time in science, you gotta work a little hard, man, a little harder. Suggest the correlation. Yeah, I mean, that would be one step even worse, I would say. Yeah, the reviewer 2 inside me is spinning. Yes, exactly. That would be a way bigger deal if it was actually general consensus that it causes cardiovascular disease. Again, it's pretty tricky. Did someone write it, then add the citations? Is that how scientific papers work? It's complicated to say. I know some people have better citation practices than others, and I'm not going to get too deeply into that. Okay, one more paragraph here, just because it's important to read the actual words, to read the actual goddamn paper. Insulin resistance has been causatively linked to development of arteriosclerosis. Sure, I don't know that. I'm not a scientist. I'm not a scientist. I'm not a metabolic or heart person, so sure. One citation here seems insufficient. Should probably have more for this claim just because that's a pretty major, but whatever. Which is the leading cause for cardiovascular disease, stroke, and other artery dysfunction-associated morbidities and mortalities. Sure. Several possible mechanisms have been proposed to explain insulin resistance and hyperinsulinemia in arteriosclerosis, including dyslipidemia, salt and water retention, and inhibition of fibrinolysis. Sure. The other important factor contributing to arteriosclerosis is inflammation, which occurs hand in hand with emerging lipid accumulation in arterial wall and participates in initiation, progression, in the thrombotic complications of arteriosclerosis. Okay, cool. I'll explain what that means later. You don't have to know about that now. Circulating monocytes interact with activated arterial endothelial cells through adhesion molecules and chemokines to promote monocyte migration, activation, conversion. Sure. Again, I'll explain these later when they become relevant. Pro-inflammatory monocytes / macrophages within intima express scavenger receptors to bind to lipoprotein particles and become foam cells, also named lipid-laden cells. If you were around for my cancer stream, you've heard of this, which exhibit the M2 macrophage phenotype. Infiltration of inflammatory cells in AP plaques also accelerates plaque growth and instability, two key pathological processes for causing tissue ischemia as seen in myocardial infarction and stroke. The mechanism, this is the important sentence, the mechanism link between insulin resistance and hyperinsulinemia remains elusive. Okay, so a whole bunch of words. This paragraph I don't have a problem with. This is hypothesizing about the connection between insulin resistance and heart disease. And as someone who doesn't understand the field, I go, okay, I buy that. I buy that insulin probably has something to do with heart disease. I can't confirm that because I don't have the time, but I'm willing to buy that for the sake of understanding the rest of the paper. this reads like AI slop. To be fair, these are not native English speakers potentially. This is a paper that, at least, you know, just judging from the last names and the institutions that they studied at, this is with a okay level of probability within the realm of like English not your first language. And because, you know, English is the language of science, we force the rest of the world to conform to that. So I am willing to give them a little bit of leeway with that. But now that you bring it up, it does read kind of not very good. But I don't hold that against them, because I just have this like, I feel it's unfair that English is the language that everyone has to conform to English when they're like writing papers. And so I will extend a level of leeway, and I think that is fair to do. Vegetative electron microscopy, true. I barely understand any of these terms, and I'm rolling with it. That's fine for now. It's fine for now. And again, I'll explain what if this stuff matters later. So I want to identify the research problem here, what the authors are trying to tackle. So artificial sweeteners linked to heart disease. I don't buy it, but that's what the authors are saying, so I will pretend like I believe it for the sake of the paper. Insulin resistance is also linked to heart disease. Sure, I don't know enough about the field, but I am giving them the benefit of a doubt. And the question they want to answer is, do artificial sweeteners contribute to heart disease through insulin resistance? So this is a mechanism paper, essentially. Okay. All right. So here's my assessment of things. Am I convinced that this is an actual problem? This is written in an unnecessarily shady way, so this to me raises a red flag, right? I'm not convinced that the problem that are purporting to care about is something that matters, but the philosophy of my advisor is to not think about crapping on a paper forever and discarding everything, but figure out what you can learn from it. There's probably some amount of research that is usable here, and you should make it a game to figure out how much of this data is recoverable and meaningful. So that's the mentality going in. I go, okay, I don't really buy that the problem is real, but sure, let's see what you found, and maybe that's interesting on its own merits. So what's the research question? It's basically trying to see if there's a connection between aspartame, insulin resistance, and heart disease. Okay, do we get that, chat? I'll take a second to field any questions about the setup before we dive into the actual paper. But this is the context here. Okay. I've missed quite a bit of chat, so it's going to take me a bit of time to go through it. What would the mechanism be? If they blame the microbiome, would that mean giving someone penicillin is really bad for them? There is some research. Some potentially more compelling research that shows that artificial sweeteners can affect the microbiome, and that could be potentially problematic. However, all microbiome research has to be taken with a grain of salt because, as Mylan can attest to, because we collaborated on a microbiome paper, it's pretty complicated linking microbiome stuff to actual real-world relevance. I cannot think of a mechanism as to how aspartame will be harmful. Actually, this paper will bring up a potential mechanism that will be interesting to look at. I'm here to find out if the Diet Dr. Pepper I drank earlier today will make my heart explode. Welcome, Mylan. Welcome. I think this will be an interesting paper. Yeah, ChatGPT. Yeah, it's not worded great, but maybe it's it's because it's not their first language. It sounds like you trained an AI model on Huberman and a supplement shill. I mean, I'm willing to give them more grace than I think a lot of people initially give. And that's kind of my point, is that like, if you find yourself reacting very emotionally to something, you gotta like crack the brakes, essentially, like halt the brakes. Like, did I get an emotional reaction? Yes. But then like, when I read the methods and results, I was a lot more calm, a lot more objective, but the introduction definitely made me go, I need to really pay attention for potential author mischievous that kind of what is it, them being mischievous, I'll just say that. Okay. I'm working on a microbiome study right now. I'm not saying microbiome is bad to study. It's going to be like really big. It's just that the translation between basic biology and something that you can do with it is very, very difficult. I feel like if aspartame was actually harmful in a big way, we would have figured out by now. Even if mildly bad for your heart, I find it hard to care because it seems like everything is bad for it. So I will unpack that attitude, I think, C.R. Smith, because that's a very commonly held attitude, but I'm going to try to sharpen our application of that attitude, I think. Okay, so I think we're good to go in talking about the actual paper. So how was the research done? So in this first set of experiments, we seek to answer the question, does aspartame worsen heart disease in heart disease prone mice? So this is very important. We are taking a look at ApoE mice, and if you've done heart research or Alzheimer's research, you would know this mouse. This is a genetic modification of a mouse that has a lipid transporter broken. So this mouse has a lipid metabolism gene that is broken, and it leaves it vulnerable to heart disease. And so what you do with these genetically modified mice is that you give them a high-fat, high-cholesterol diet, and they develop heart disease very reliably. So you split these ApoE mice into two groups. You give one group high-fat, high-cholesterol, no added sugar for 12 weeks, and then you give the other group high-fat, high-cholesterol aspartame for 12 weeks, and then you check their heart. Okay? So I want to just kind of check, chat, what do you think about this experiment? So this is the experiment, and then this is the question that this experiment seeks to answer. And I want your opinion on how this is run. What do you think? Is this a good experiment? What would you say? Hello, I'm afraid I won't be in chat very much today as I'm trying to multitask, but I'm here and I'm really excited to learn. Well, I'm glad that you are here, Beastbone. Why no control given just added sugar? It's a good question. We'll keep that in mind. What do y'all think? What do y'all think? Why are they adding fat again? They want these mice to get heart disease. That's a good question, though. It's a good question, though. Wait, I thought ApoE mice were used in Alzheimer's model? Yeah, they're used in Alzheimer's model that have a particular hypothesis about metabolism, which is why this paper, I saw ApoE and I'm like, ApoE, that's the Alzheimer's mouse. Well, that's because I'm a brain person, right? So that's my background coming into play. The ApoE mouse is a common Alzheimer's model for if your hypothesis is that Alzheimer's is metabolism based instead of, or you want to study the metabolism aspect of Alzheimer's, I should put it that way. Shouldn't we be looking at aspartame only? Why not normal diet? What's the control? Control doesn't make sense for humans. Should have added sugar and aspartame. No sugar, sugar, aspartame, fat and ApoE to accelerate osteoporosis. Okay, not a bad idea. Duration of aspartame intake is quite low. What if aspartame just affects ApoE mice? So these are all really good questions here, and I just want to hone in on the fact that we have a very defined experimental question here. Does aspartame worsen heart disease in heart disease prone mice? Okay, so I'm actually going to say that Guy is got the right interpretation here. They're adding fat and ApoE mutations to accelerate atherosclerosis. Not a bad idea. Duration of aspartame intake is quite low. That appears to be okay, I think. I mean, you wouldn't know that a priori, but that appears to be okay as we're about to see. But the reason why I think Guy has the right take here is because what chat is experiencing is a very normal reaction. A very normal reaction to be like, there's no control here. And that's because chat, your question is different than the experimenter's question in this part of the paper. Your question is, does this matter for humans? The research authors in this particular subsection are asking, in mice that are vulnerable to heart disease, does aspartame make a difference? And I actually think this experiment is fine. Not great, because I want to see those controls just like how you want to see those controls. But Guy has it right. The thing is that you can't guarantee that an ApoE mouse gets heart disease. They are more vulnerable to heart disease. You still have to give them heart disease. The way that you give them heart disease is high-fat, high-cholesterol diet for 12 weeks. And then you either test the effect of no added sugar or aspartame. And again, chat wanting a sugar control, like no sugar, sugar, and aspartame, I totally agree. I want to see that too, because I'm curious. But I will say strictly for the purposes of this very narrow research question, I think this is okay, but misleading. Like, you're right. This experiment kind of sucks, but I think technically passes. Technically passes. Very, very much technically passes. I'm not mad. I'm just disappointed. I'm pulling the dad card. I'm not mad. I'm just disappointed. Okay. But Guy is right. I agree with Guy. I'll put it that way. I agree with Guy. We have to do this to the mouse to actually give them heart disease. And then we can see if aspartame is worse than doing nothing. Okay. And that's an okay place to start. I want to make sure that chat understands my position on this. That's, in my opinion, an okay place to start. Okay. So yeah, so there are two major caveats that we have to keep in mind. It doesn't kill the paper, right? I don't think we should get mad at the paper for this because, again, it's a disease model. It's going to be artificial because you have to give the mouse a disease, right? So that's fine to me. But then the writing, come on, dude. But then when you see the results and when you see them write about it, this is a major pet peeve of mine. Okay. Like, this experiment design is fine. I think it's fine. It's a good place to start. But then this is how they title their results. Aspartame exacerbates atherosclerosis in mice. No, if you're going to do this, like, kind of not okay, like kind of shaky, very preliminary study, you should be honest. Aspartame exacerbates atherosclerosis in ApoE mice. You should be honest. There's no harm in it. If you put ApoE mice here, I don't have the pitchfork out. But because you are hiding, you are being deceptive by not being straightforward with your science writing, and that makes me mad. It's disappointing. You're making me agree with Redditors, and I hate that. Do we have the original text in the original language? Was something lost in translation? Something like ApoE, that can't be mistranslated here, right? Even if it was in the original language and they wanted to be honest about the type of mice they were using, they would put it in here. In fact, most papers would be upfront about the limitations in their model because it's not actually a weakness, right? Like, I'm making the same argument as Guy here. Like, this is a fine experiment to do. I mean, you want to know more. You want there to be controls, but that's because we immediately think about human health. But if we're thinking about this very narrow question, then this is a fine way to address that. Because we're not asking if here, look, notice that this question that I pose up here, this does not have anything to do with normal sugar. We're not asking, is aspartame worse than normal sugar? We're asking if aspartame is capable itself, if it's capable of worsening heart disease. So this is actually a perfectly fine experiment. There was no reason to hide that here. And that is annoying. That is very, very annoying. Mice, bro, that's a very specific type of a very specific strain of mice. Exactly. It's again, it makes me want to stay on my toes. So let's take a look at the data here. So aspartame increases the presence of atherosclerotic plaques. So this is a mouse. Oh, by the way, I should have said this earlier, but if you're uncomfortable with looking at organs, I forgot to include warnings, but just kind of be aware. This is a mouse aorta. It's been dissected so that we can see the internal plaques. The square box is the area that we are analyzing, and basically the redness of that area is like the red dots are a dye for the plaques, essentially. And so we have the vehicle. So this is a regular diet. Sorry, not regular diet, high fat, high cholesterol diet, no added sugar. That's what this aorta is. And then we have 0.05% in their food for 12 weeks, 0.1%, and then 0.15%. And the percentages are given by weight, which is a thing that I'll get into a little later. Forbidden Twizzler. Okay. And so I'll say, I definitely see more in the 0.15% aspartame than the vehicle, which means that aspartame is in fact capable of worsening heart disease. I think that is fine, right? Is it worse than sugar? We just have no idea, but is it worse than not adding anything? Yeah, and I think that's an important piece of the puzzle to understand, that if you are genetically predisposed to heart disease and you are given a high-fat, high-cholesterol diet, could aspartame make things worse if you're a mouse? Yeah, I think that is uncontroversial here in terms of just this data figure, okay? But that carries a lot of weight because that doesn't translate at all to humans, right? There's no conclusion that can be made to human biology with just this one data figure. But for this mouse, yeah, I agree. So something should be buzzing in your head though. What percentage is this? Like mathematically, how much aspartame are these mice getting? So I did some back of the envelope calculations. 0.05% weight by weight for aspartame is the same concentration of aspartame as is in diet soda. So this lower bound, again, my calculations, they might not be like super correct, but I did make a pretty good effort to try to like figure this out legitimately. And I have some sanity checks to back me up here. So this mouse got like the mouse equivalent of about a can of diet soda, in the realm of a can of a diet soda for the mouse body weight. The mice were given 200 microliters. So sorry, yeah, back of the hand calculation. So yeah, sorry. Let me back up. This concentration is roughly the same concentration as diet soda. The amount of that soda that the mice were given was about a third of a can a day, equivalent to humans, right? So if a mouse drank a mouse-sized can of soda, it would be the mouse equivalent of 1/3 can of soda. Does that make sense? Does that make sense, chat? So they are drinking some level of clinically relevant diet soda. I'll put it that way. Well, not actually diet soda, but in their food, they're getting the equivalent. What's the vehicle column? It's high fat, high diet, no high fat, high cholesterol diet with no added sugar, no added aspartame. Yeah, okay. But mice are much smaller, and this is my back of the hand calculation. So I decided to do the calculation in a different way, which is to use the FDA recommended maximum dosage, right? So here's a Reddit comment that purportedly did the math. The recommended maximum daily intake of aspartame is 40 mg per kilogram in Europe. This is the same thing in the paper that we saw. Average soda using aspartame contains about 200 mg of aspartame. That's also what I found. So you can consume about 1 can per 4 or 5 kg of your body weight per day. If you weigh 70 kilograms, you can consume about 14 to 17 cans per day, presuming no other sources of aspartame. For comparison, the mice were given the equivalent of 500 to 1,500 mg per kilogram, basically 10 to 30 times the recommended daily maximum. This isn't entirely pointless as mice don't live as long and there's a need to accelerate the effects. And that's exactly what Guy and I are saying, that like artificial experimental conditions are not necessarily by themselves the death knell for a paper. It's possible that humans could develop similar effects through sustained high intake levels over a much longer period, even if it stays below the daily maximum. So I could have just said yes to this, but it's Reddit, and Reddit is wrong all the time. So I did the math. So 0.2 milliliters, I converted it from microliters times 0.0005 grams of aspartame, right? This is 0.05%, moved the 2 decimal points. You can check I'm not a great mathematician, so it's possible that I made a mistake here. But, just converting the weight per weight volume is 0.0001 grams of aspartame. The mice that they were using average about 26 grams at that age. So if you take the calculation, they are consuming per day the equivalent of 4 mg per kilogram, which is nowhere near the 50 milligram per kilogram limit. So from my calculation, again, I could be wrong, but my calculation says that this Reddit comment is incorrect, which is always why you should double check Reddit math. Okay, so as a sanity check, this is a professor of chemistry. Given a diet drink that contains 200 mg of aspartame, I would have to drink the equivalent of 20 cans a day per diet soda. So if you multiply what I calculated the mice were getting times 20, you get 80 mg per kilogram, which is also in the realm of the limit of acceptable intake, right? So 80 is a lot higher than 50, but it's in the same order of magnitude, which means my math is likely about correct, right? So this is a somewhat physiologically relevant amount of diets of aspartame that they're getting. So that's actually really important to note, right? Because you could make the argument that they're getting plaques because you're pumping them full of aspartame over 12 weeks, but actually they're not getting like a crazy amount and they're seeing effects. Again, heart disease prone mice, high fat, high cholesterol diet. It's a very artificial system, but in this artificial system, aspartame does in fact have an effect. Okay, so if you take that aorta and you quantified the plaques, this is what the actual numbers look like, and then you can see significance bars. It does look like there's a dose-dependent effect of aspartame in these ApoE knockout mice over 12 weeks of feeding, right? So you feed them a relatively okay amount of aspartame over 12 weeks, and they do have plaques in their hearts. And that is interesting, right? That is not nothing, right? The Redditors are like, this is lies, this sucks. You know, as long as they're not lying about their data, I think that this actually is potentially an interesting result, right? Is this enough for me to be like, I'll never eat aspartame ever again? No, because the Redditors are right, and the fact that this is ApoE mice, high-fat, high-cholesterol diet in a mouse, it's not a clinical study. I'm not scared at all. I'm going to continue drinking my protein powder, right? But in this system, it shows that aspartame interacts somehow with the heart, and that is important to know, right? Just from a basic biology perspective. Are the circles outliers? So each circle is a data point, and you can see that there are error bars. It's probably standard error. So this gives you an idea of the variance in their data, although myelin can... I'm afraid that I'll come out statistics when myelin is around because they're so much better at statistics than I am. Yeah. Wait, how many mice is it per cell? These are each circle is an individual mouse. So the fact that there are low ends, I'm not worried about that either. Like, mouse studies are typically, you know, you don't want to sacrifice that many animals if you don't have to. So like, but I'm also not like a biostats guy, so I don't actually know what the appropriate amount is. It's just that when I criticize a paper, I typically don't look at the statistics because I'm more qualified to talk about study design than I am to talk about the minutia, not the minutia, that's reductive, but the nuances of statistics. That's not my particular field. So if there's something wrong with the statistics, I'm likely not to be able to catch it. But I don't need to be a statistics master to sniff something that smells suspicious. So I'm not going to be too mad about the low end. Low ends happen all the time in biology. Okay, so the results so far here. In mice lacking ApoE, which is the fat, this should be lipid transporting protein, not fat metabolizing, but whatever. Daily consumption of a somewhat clinically relevant amount of aspartame is associated with heart plaques. Again, very artificial system. How clinically relevant is ApoE for human health? Keep that in mind, right? Like, I don't think there's a reason to freak out over this. But what I will say, again, thinking about what we can learn from this paper, there is a connection between aspartame and heart disease. How strong is that connection? We just can't know so far, but the connection is there. And so, you know, I think the attitude of like, well, everything causes cancer is technically true, but in terms of when we understand the details, the more we understand about that interaction, the more we can actually do something about it. So we don't even know yet if this is something worth enacting action over. So the next hypothesis that the authors want to test is this effect mediated through insulin? And as people have been saying, does aspartame affect insulin? Like, aspartame isn't sugar and insulin is released in response to sugar. So a little bit of background before we get into this. So insulin is a molecule that your body secretes, that your pancreas secretes to bring down the blood sugar levels. And so this signaling is screwed up when you have diabetes, right? Your cells stop being able to respond to insulin, and so your blood sugar remains high, and that can cause all sorts of complications. So that's the job of insulin, to bring down the blood sugar levels. And so people are right to be skeptical. Aspartame isn't a real sugar, so why would insulin matter in this story? And here's where we're going to get into some also interesting findings. So aspartame consumption increases blood insulin level in ApoE mice. And this was very surprising to me. So I'm not a doctor, right? I'm not a human doctor that understands all the human systems. I pretty much only studied cells, and then I went right into the brain. So it surprised me to see that in this genetically modified mouse, that aspartame consumption increased blood insulin levels. And you can see that here. I would say that, you know, just eyeballing it, it looks pretty good in terms of vehicle versus the highest percent of aspartame. Yeah, the spread to me doesn't like trigger anything unusual to me. And that's surprising, right? That's genuinely surprising. The stars here represents levels of significance, although I think stats people will argue in terms of... So we have an artificial, not an artificial, we have an agreed upon cutoff for a p-value of less than 0.05. This is just stats talk for a numerical output for a level of certainty that data is real, or that a probability that we reject a null hypothesis. I'm like, again, Mylan's in chat. I'm like, oh my God, please correct me if I'm wrong, Mylan. And then the dots are the results for each individual mouse. So we're measuring insulin levels from the blood of these mice after they have been given aspartame for 12 weeks or not aspartame for 12 weeks. Okay. So that should surprise everybody. It certainly surprised me. If you're a doctor, this maybe doesn't surprise you, but as a human health novice, it's certainly surprised me. But I thought, okay, we have a really weird genetically engineered mouse. Maybe this is a quirk for the genetically engineered mouse. I'm not going to think too much about it. And then, so that's just insulin. So let's take a look at their blood glucose, right? So 12 weeks of aspartame and 12 weeks of sucrose produce similar glucose spikes in ApoE mice when given glucose injection. So the way that this works is that you make the mice fast for, I think, a day or half a day or something, and then you give them an injection of glucose. And if their insulin is working, so that's why we get a spike in glucose level, right? At 0 minutes, that's when you inject them with glucose. You get that sugar spike, and then insulin starts to work, and then you get a decrease in blood sugar. So if your insulin system is working correctly, you should see a nice drop off here. So what we do see is that in the mice that were given sucrose, so regular sugar, here's that control. It wasn't there before, but now we have a sucrose control and an aspartame control. And we can also see that aspartame and sucrose treated mice, they respond similarly to glucose injection, and they are different than the vehicle. So that's interesting. It looks like if you feed these genetically modified mice high fat, high cholesterol, sucrose, and aspartame, sucrose or aspartame, that their blood sugar levels react similarly. And if you don't give them either sugar, then they are able to bring down their glucose level. Although it's kind of tricky to interpret because the baseline sugar spike is like the height of the sugar spike and the decay rate. It's a little hard to say. What we can say is that by the end of 2 hours, the mice that were not given supplemental sugar have lower blood sugar than either the sucrose fed or aspartame fed. And that is curious. Whether or not it's because they spike higher and their insulin is doing something and their insulin is acting normally, we don't actually know yet. But we can say that after 2 hours, they have higher blood sugar. So that by itself, this is tricky data to interpret, but it shows that, okay, their blood sugar is reacting, their insulin is reacting differently, potentially, right? Because their blood sugar initially spikes way higher. So the fact that it doesn't reach the same high, that the non-sugar treated group doesn't reach the same high, is indicative that insulin is screwed up somehow. And from this data alone, it's not entirely sure how. Yeah. How many individual mice were subjected to these experiments? Is it enough to get statistical significance, or could it be a fluke? You do what's known as a power analysis to get a ballpark idea of how many mice you should need, but as Mylan can tell you, power analyses are philosophically a tricky test to justify. And so Mylan is absolutely right that you would need a minimum 30 people per cell, but you actually don't want that in biology research because we have a very strong, at least in the US, we have a very strong culture of making sure that mice, like animals, are treated fairly, right? Like if you don't have to kill 30 mice per condition, don't. And it also, because the taxpayer cares too, right? Like you don't want to know that your tax dollars are going into a lab that needs 30 mice per condition, which can be hundreds and hundreds of mice per research paper. It's just not, and also it's expensive, right? Not only is it morally not right to use an excessive number of research animals, it's just also like impractical. So it's a limitation in biology research that we have to be aware of, put it that way. Okay. Yeah. Okay. So insulin is acting funny even in response to aspartame, and that is very, very interesting. Again, assuming that they didn't lie in their paper. So let's take a look at blood glucose when they're given insulin injections. So this is kind of honing in on an insulin hypothesis, right? So this is blood sugar. Blood sugar spikes when you give a glucose injection, and then it goes down due to the body's natural insulin. Now we are doing 12 weeks of aspartame, 12 weeks of sucrose, and then we add in insulin, right? We inject insulin and check to see if that is capable of lowering their blood sugar. So when you have the normal ApoE mice eat a normal diet, you give them the insulin, you do get a drop in blood glucose, although I don't think they compared time 0 to time 60 here, which is kind of unfortunate. And because they all start slightly different in terms of baseline sugar, it's kind of a headache to interpret, honestly. But what we can say is that it kind of looks like the blood sugar remains pretty stable in either the sugar diet and the aspartame diet. In fact, the aspartame just kind of looks the worst. Although, again, because the baselines are different, and that's kind of annoying, it's a little hard for me personally to really put a lot of stake into this. But it does look different enough from where I buy the idea that insulin is screwed up. I buy the insulin is screwed up here. Yeah. With error bars that small, it looks like vehicle goes significantly down. Yeah, I would buy that because the error bars are so tight. But it looks like the treatment group is experiencing a lot more variation of variability, which is kind of interesting. Okay, so the mice lacking ApoE, so this is genetically modified mouse, daily consumption of aspartame is associated with heart plaques. Is this mediated through insulin? Potentially. Aspartame consumption is associated with blood sugar dysregulation. I'll say that much, right? Insulin, I don't know, whatever, maybe. And then the next interesting experiment that the researchers do is they go to monkeys, and that is really weird because in the US, I don't think you could do that. At this stage of the research, I don't think a US-based researcher could be like, oh, we just have a monkey that we could do this to because monkeys are ridiculously expensive. But okay, they do this in monkeys. And here's what they found. Or rather, I will let you look at this because I think this is a moment where I looked at the data and I was like, I'm actually like shocked. I'm actually so surprised. So this is a one-time feeding study. So the mice studies were 12 weeks, so trying to chronically give them heart disease. This is a normal monkey, and then they gave them a feeding. So normal monkey, you fast for 12 or 24 hours, can't remember which, and then you get some food, and you get a dose of something. So either you get nothing, I think, in the vehicle, or you get an injection of sucrose, or you get an injection of aspartame. And so on the left here, we're looking at insulin levels. Again, insulin is released in response to sugar to bring the blood sugar down. And then on the right, we get blood glucose levels. And here's a really good moment to engage with the data. Now that I have modeled how to interpret the data, you can actually look at the data yourself and come to your own conclusions. And so I looked at this data and I was really, really shocked. And again, these are normal monkeys. These are normal monkeys. Wait, why are there no error bars at all for 30 minutes for the vehicle? 30 minutes vehicle. They might not have had more than one monkey there. Again, like monkey studies are like super duper expensive, which is why like when I was doing biology, you would think that like monkey brains would be really important in neurobiology research, and they certainly are, but most of what I read was in mouse because monkey is such an extreme model organism. So it's very possible that for whatever reason, that time point only had one monkey, or the error bars are ridiculously small. I don't actually know. This feels like quite a jump from mice to monkeys, as they're trying to prove this for mice, like the paper said, are trying to say something about humans. It is shocking that they went to a monkey, and nobody in Reddit was talking about the fact that they went to a monkey. Like, this is kind of crazy, honestly. A monkey is a better model organism for human health than a mouse. I mean, that's for sure. But what do you think about this? Does the dot mean the values are all the same? The dot means the values are different, and so you can see what these comparisons are. So when you see a blue star, you see that the difference between blue and black is real. We'll put it that way. That difference is real. Red star means that the red and black are different, and then this gray star means that the aspartame and the sugar are different. Yeah. So I just wanted to pause here to kind of sort of take this in, I guess. Okay. So this is crazy, right? So when I'm looking at this data, A monkey had a relatively normal life. I would say that this is a pretty good approximation of a human being. When they eat aspartame, they get an insulin spike. Does that surprise anybody else in chat? When the monkey eats aspartame, normal monkey, normal life, nothing that freaky happened, they eat artificial sugar and their body reacts like it's real sugar. And that's crazy. This is burying the lead. Nobody in the Reddit comment section is talking about this. This is the actual thing that I'm surprised by as someone who's not like a metabolism person. Yes, that confuses me. That's super interesting, isn't it? Like there's stuff here that is good, right? This is a Cell paper. There has to be something in this paper that is worth looking at. Hey Z, welcome in. We're talking about aspartame. And the fact that, okay, so Z, you came in a really good time because we're about to pivot. This paper is about to take a crazy turn. A normal monkey lived a normal, healthy life, no genetic modification. That monkey eats artificial sugar, aspartame, and their insulin spikes. And insulin, as far as us novices understand, is released in response to eating, the presence of sugar, right? We commonly know when we're talking about diabetes that insulin is released to bring the blood sugar levels down. But when the monkey eats aspartame, it gets the same insulin spike as actually eating sugar. That's actually bonkers, right? How much attention do the authors bring to this? Not that much. It's actually kind of buried because they wanted to do more monkey tests and they were not able to, because again, monkeys are just so expensive and troublesome and like a big headache. So they actually de-emphasized the monkey research, and like it's not even mentioned in the like abstract or introduction, right? And again, because Redditors don't actually read the paper, none of them caught this. Okay, so let's dig into this finding that aspartame is sufficient to cause an insulin spike. So why might that be? So this is actually a well-known phenomenon. This is called the cephalic phase of the insulin response. So the insulin response has a couple of different circuits, and the circuit that is activated first is the cephalic response, which is triggered by the sight and thought of food, right? Just thinking of eating causes your insulin to spike. And so it makes sense that the act of eating aspartame or sugar would have potentially a similar effect on the immediate spike of aspartame. And that's really, really interesting. So this is a well-known circuit that we've known for quite some time that does not rely on the nutritional value of the actual food in order to produce an insulin spike. And that is bonkers. Was there a reason they did this in monkeys, though? I feel like you could just feed humans sucrose and APM. I think it's just the limitations of what their lab was capable of doing, right? Like, it's really hard to do human clinical stuff. You have all sorts of different research ethics boards you have to pass. You do have to do it for monkeys, too, but, it's not as big of a deal to do it in monkeys than it is to humans. But Toxo, you are on the right track in terms of thinking about curious questions. So previous research, thank you Toxo for this beautiful transition. This is a paper from 1988. This is a very low-end human study that shows that insulin spikes after aspartame consumptions in humans. So you kind of don't have to do this in a monkey because we kind of already know that this happens in humans. And I think they included the monkey research because they wanted to follow up on it and couldn't, and then they just had the data, so why not? I forget what NIDDM patients are. I think this is maybe the hospital they were at, but I'm not sure. There's a second, this is a clinical trial down here, cephalic phase responses to sweet taste. So this is worded very deliberately, where they had a clinical trial and they measured insulin levels. And both of these papers found that the ingestion, or I should say that the treatment of aspartame, because it might not be the ingestion that's the issue, but maybe just the act of putting it in your mouth or anticipating it, is capable of spiking insulin. So that's very, very interesting, right? That's really cool. So insulin spikes regardless of what we're able to consume. Like if I decide to eat cardboard, would it happen too? I'm not like a medical doctor, so I wouldn't be able to tell you, but according to this, like cephalic phase research, there's some level of brain anticipation and mouth sensation that causes that insulin pathway to upregulate. Okay, So, of course, there's this Reddit comment. Artificial sweetener aspartame found to spike insulin levels in mice. Cool story. Doesn't in human RCTs at doses of up to 1,050 milligrams a day for 12 weeks. Next. Just so confidently snarky. This is the like the umami salt in the Reddit comment section of this paper. This is why it was so much fun to read this paper and just bathe in like people being wrong. But they linked the paper, so I go, okay, maybe there's something to this. So I click this paper. You can see that the link is purple, and I read the paper. So what is the paper that this very big brain Redditor cites? What is this paper? This paper says aspartame consumption for 12 weeks does not affect glycemia, appetite, or body weight of healthy lean adults in a randomized controlled trial. So 12 weeks of aspartame consumption does not change blood sugar levels after oral glucose. So they are challenging. So they get people on this 12-week aspartame diet. Then they fast them, then they challenge them with glucose that they take through the mouth, and then they measure their insulin spike, right? And they find that their insulin doesn't spike heavier than the equivalent control, which is interesting. But this is a chronic effect. This is not asking the same question. This is asking, does chronic consumption of aspartame change the way your body reacts to sugar? It doesn't ask the question that the one-time intake of aspartame spikes insulin. So this is just wrong. This is just wrong, dude. This is so wrong, dude. This comment that this person is responding to is correct. In this paper, artificial sweetener spikes insulin in mice. I already showed one clinical trial and another research paper that found that the cephalic response is engaged just upon like the sensation of eating, right? So it maybe isn't even aspartame specific. Just consuming something raises the blood insulin. And so, yeah, this is not. It's not. This paper doesn't address that is not the conclusion. Okay, here's the thing. It is against my moral fiber to make fun of people for not understanding, right? Because vtheorem is about, science communication, and there are no stupid questions. But there is being stupidly confident about being wrong, and if you do that on the internet, I will lightly make fun of you. If you are going to criticize a paper, it is a requirement to read the paper if you are going to do it. Otherwise, I am going to roast you. If you don't want to be bullied by a blue neutrophil online, don't criticize a paper without reading it. It's so good. And the snark. Next. Next. Oh god, it's so good. I love it. I love reading Reddit comments so much. They hurt me. This is absolutely like digital self-harm, where like I'm like, oh god, these people. But yeah, to my audience, I know you would never do this, so join me in laughing at how wrong this person is. Has anyone ever tested aspartame injection in animals? Would be interesting to see if that raises insulin. So I don't know if you were here earlier, Mandrake, but it does in these genetically modified mice who are eating high cholesterol, high fat diet. Okay, so yeah, that's not what the paper says. It's testing a chronic response to aspartame, not a one-time sugar spike or one-time insulin spike. Okay, so with that out of the way, let's kind of review for if you're just joining. Mice that don't have this critical fat transporter protein, if you drink aspartame every day for 12 weeks, you get more heart plaques in a disease model of heart disease. At this point, we don't know if this matters for humans. It's just interesting to know that it's true for the mouse. Is this effect mediated through insulin? Potentially, like it's not no at this stage, but it's also not yes at this stage, right? We see a correlation, right? Aspartame consumption is correlated with insulin spiking, which is correlated through heart disease through some other papers. And does this happen in a more clinically relevant model? Potentially a one-time treatment of aspartame spiked sugar. We kind of already knew that in humans, so I don't really buy that we needed to do this, but maybe I didn't read that part very carefully. So whatever. However, this is not a one-to-one experiment with the mice, right? Like the mice had 12 weeks and then the monkey study was one time. So they're actually asking slightly different questions. So we have to keep that nuance in mind. Word of the day is nuance. So here's the big the big question here. Can insulin spiking result in heart plaques? Because if we have all the pieces of Exodia, right? Like if aspartame triggers insulin, and if insulin triggers heart plaques, then we got a stew going, right? Then we have something worth talking about. So let's see. So ApoE mice, they were hooked up to a machine that pumped them consistently with insulin. So they raised their blood sugar levels, not blood sugar levels, sorry. They raised their insulin levels very slightly for an amount of time that I don't remember. For a week, it looks like. So area of plaque vessel ratio of 4 week of feeding. So in the group that was given circulating insulin, you had larger heart plaques, right? And that's so not only the area to vessel ratio, but also just the area as well. So you can see here that the insulin hooked up mice to insulin, just given insulin, this ApoE mice, they get heart plaques. Okay, so that is a stew, right? And here's the other actually good experiment that they did coming from the opposite direction. So giving the mouse insulin gives them heart plaques. Cool, interesting finding. A very good experiment that they did afterwards was to destroy the pancreas to see if aspartame still gives them heart plaques. And what they found was actually very compelling. When you destroy the pancreas by giving them this poison, you actually find that aspartame no longer gives them heart plaques. Isn't that cool? I think that's pretty cool. That's a good experiment. Destroy the pancreas? Yeah. So they want to see if this effect, this insulin effect, is mediated, they're trying to make the link between aspartame and insulin, because right now we have a bunch of blocks that don't connect with one another. So let's put it this way. The model that we're trying to test is aspartame creates heart disease by using insulin. So if we stop the mouse's ability to make insulin by destroying the pancreas, does aspartame still give the mouse heart plaques? And it actually looks like when we destroy the pancreas, aspartame no longer gives the mice heart plaques. The potential insulin connection, exactly. So actually, this is a pretty elegant experiment, right? This is getting closer to causation, right? Now, it could just be that when you remove the pancreas, you're not able to get heart damage in any kind of way. Like maybe the pancreas is required for heart damage, period. But it looks like aspartame, this is decent evidence to show that aspartame needs insulin, because when you remove insulin by destroying the pancreas, you no longer get heart damage. Wait, the mice are made to have accelerated atherosclerosis, and removing the pancreas without acting on cholesterol corrects everything. With regards to their reaction to aspartame, I mean, they're still getting heart plaques, right? Like these are still prone to heart disease, but that effect that we saw earlier of the aspartame worsening the heart plaques, we're no longer seeing that. NS stands for not significant. So no aspartame, yes aspartame. We no longer see that effect. I think this is a pretty interesting finding. That explained a lot of other papers I've read that suggest aspartame is most dangerous in people with diabetes. I'm like an aspartame novice. This is the first real aspartame aspartame paper I've ever read. So I'm just taking this in, like trusting the author implicitly, right? Okay. Maybe metabolic in the pancreas or something in the pancreas releasing. That would be insulin saying. So they're testing whether or not this connection is mediated through insulin, because the pancreas is the organ that I almost said organelle because I'm a cell biologist. The pancreas is the organ that makes insulin. So this is actually a good finding, right? So this genetically modified mice, they eat aspartame, they get heart disease. Don't read too much into it. Is it mediated through insulin? Actually, probably yes. In ApoE mice in this artificial system, it looks like it is actually mediated through the pancreas, and we know that the pancreas makes insulin. It's not a perfect, as Sang is maybe suggesting, the pancreas could do other things, right? It might not be insulin. It could be some other cryptic thing that the pancreas is making that aspartame is working on. But it's pretty good, right? Like maybe you could have used antibodies against insulin specifically instead of a pancreas poison. But at this stage, I'm not that picky, right? Like to me, okay, like maybe the pancreas is doing something else, but I'm buying at least, you know what? Thank you, Sang, for kind of helping me be a little more careful, because we shouldn't fill in the blank for the authors. We have to be skeptical because their writing was so deceitful. Can insulin spiking result in heart plaques? In ApoE mice, technically, thank you, Sang, there's a connection between the pancreas and ApoE and insulin and heart plaques. We can say that, right? Heart plaques, pancreas, there's a connection there. And I think the connection is likely to be insulin. I think that is where we should be in terms of where we are technically thinking about. Yeah, so that's a really good point saying. Does a pancreas in a mouse do the same things as a pancreas in a human? Reasonably so, reasonably so. The mouse is not a bad model for human biology, it's just not perfect. So next question that the author asks is, how does aspartame consumption in ApoE mice lead to heart plaques? So we have the connection, right? Our working model is that ApoE into insulin into heart disease. So what is the mechanism? What are the molecules involved? I'll put it that way. So chat, I want to take a little bit of a break while I hydrate to allow you to think of a potential experiment that you could do to better elucidate. Oh, sorry, I'm burping all the time. Sorry. So I want you to come up with an experiment to help us understand the molecules behind this interaction. ApoE to insulin to heart plaques. So I'm pulling on my biologist here. Why did they mention lipid-laden macrophages earlier on? We're going to get that. We're going to get to there, Azir. We're going to get to that. He needs to osmosis some water. Yes, I do. I need to osmose some water right now. That is good, unsweetened water. We have aspartame and insulin. So what do you want to do with that? Insulin-like growth factor, perhaps. Lay out an experiment for me. What would you want to do to figure out what molecules are relevant in this story? And usually I say to hold off on the biologist answering, but if there are biologists answering in chat, like this is a bit more of an advanced kind of setup, right? This isn't so obvious, but I do think that it would be fun to see if chat could get an experiment that I would agree with. Only for ApoE, yeah, exactly. We're only working with ApoE mice here, these heart disease things. Knock out insulin and see if aspartame still leads to plaque. That's a great experiment, Mylan. I don't know if an insulin knockout exists. They must exist in some capacity, but that's not what they did, but that would be just as good or even better. You know, actually, that's a better experiment than the pancreas poison experiment, because that rules out some other thing that the pancreas is doing. I sympathize with them because it's easier to give the mouse the poison than it is to get another mouse. Just like it's more expensive to get another mouse and a lot less practical. But I think that's a good experiment. That doesn't give you a lot more information other than the pancreas dependent part of that previous experiment. So definitely a good one that they could have done, but not where they go next. So I agree, that would be cool to see, but they wouldn't give us a lot more information. Anti-insulin antibodies given to both groups of mice. So that's also the line of what Mylan is talking about with regards to confirming what we already know. We want to learn more about what is happening under the surface. We could tag the aspartame. So Alexandros, that would give us information about where the aspartame is going. And if you think about what you could learn from that, it's not immediately obvious that that yields anything actionable, right? Like, I think that would be neat, but there's risk involved because you might not learn anything interesting. Does more insulin make it worse? Okay, so we'll take that because that is closer to what they do. So does more insulin make it worse? So that is part of what they end up doing, for sure. We don't want to know the effect. We already know that there's a connection. We want to know how it works. We want to know what molecules are involved. Yeah, this is a tough one. Can we do a biopsy first to see what's in the plaque? The plaque consists of many things, maybe compared to normal mouse plaques. So saying that's an interesting experiment, but that hypothesis is a bit too targeted. That is fishing for a result. And that is not, the chance that you find something interesting is not that high with that design. That doesn't mean that that's a bad idea, but a scientist would potentially look at that and go, we need more justification for that. So I'd say that's an interesting experiment, but not necessarily the next step that you would do here. Replace aspartame by insulin in a control group. Yeah, so that's more like a validity thing. We're assuming that the authors are right here. Dialysis in the blood to remove insulin, then see if it still happen. I love all these because these are all rigorous answers, but I will go ahead and go to the next slide because it looks like this particular experiment is a bit hard to come up with. So again, the relationship is okay. It's a little shaky, but there is a line that they draw. So the next they want to know is how is it happening, and not is it happening, because the experiments that Chad is suggesting are more in the line, still in the line of, is this relationship real? They want to know what is going on in the cells themselves. So for that, and again, this is why I was like, there's a chance that Chad doesn't get this, and that's totally fine. This is like a biologist question. We're going to take the cells of the heart, and we are going to give them insulin, as Myelin had alluded to. We're going to take pure heart cells, add insulin, and then we're going to check what proteins, not what proteins, but what genes those heart cells are expressing, what RNAs are being made, because this gives us the how. We have the relationship, aspartame into insulin into heart disease, but we want to know how. So one way to investigate that is to take the heart muscle, the heart cells themselves, give them insulin, and see what genes are you actually expressing. And I say that very carefully because protein is not a part of the equation. Protein is implied here, and that matters if you're a biologist. If you're not a biologist, it doesn't really matter. And so here we have a heat map, and we are comparing heart cells. These are I don't remember if these are ApoE or wild type heart cells, but whatever. These are some heart cells. And the more blue the bar is, the lower that gene is expressed when you give them the blood sugar challenge. Wait 1 second. Is this chronic insulin? Sorry, 1 second. I might have the details on this experiment wrong. 8 hours insulin, RNA-seq, you get vehicle. Okay, so one group did not get insulin, the other group did get insulin, and then we want to see relatively their gene expression compared to what? I'm a little confused as to what vehicle is compared to, because this is -2. Okay, this is me being picky about this. The general idea is that the more red it is, the more of that RNA is being produced, and this column tells you what RNAs are. And so if you're not an expert, this doesn't really mean anything to you. There are all sorts of genes here. I don't really know any of these genes, but I actually do recognize this top gene because this has the format of a chemokine. In other words, an immune signaler, CX3CL1. I don't know this particular chemokine, but this looks like a chemokine to me. So in the vehicle, these are the genes that are, these are the genes that are lower, and then these are the genes that are higher compared to something. We're just gonna not think about this one. And then the insulin group, these are the genes that are upregulated, and each column here is a replicate to show you the consistency. And so the topmost, the one that is most consistently upregulated, is this chemokine CX3CL1. So it looks like when the heart cells get insulin, they are pumping out the RNA for this gene. And so this is now starting to investigate how this relationship is actually unfolding. Why aren't they looking at macrophages if they are important in heart disease? We're about to get to that, Mandrake, right? We don't have the justification yet because there's nothing that implies that macrophages are involved. That's taking a shot in the dark until right now, because CX3CL1 is an important gene for macrophages. It's an important gene for macrophages, and that's why macrophages are in this story, okay? Okay. If the mouse cells are not in the mouse, aren't they dead? How are they still reacting? We have science for that. We can buy particular media, basically batches of cell food that keeps them alive. Okay, so this is our gene of interest. This is the gene that the heart cells are making RNA for. So we're going to see what the heck is up with this. So what is this mystery protein? So before we get into that, this is just like for my bio nerds out there. We got to make sure that the protein is actually upregulated. So they do, you guessed it, a Western blot. So basically the darker this band is, the more protein is there. And then you compare that to a gene that's not supposed to change at all, GAPDH. So basically you can kind of see in this blot that there is a heavier blot for a CX3CL1 in the insulin treated heart cells than in the vehicle. It's slight, but you can make it out here. And you can see that reflected in the group here too. So again, for my biologists out there, anytime you see RNA-seq data, it almost should, it should almost always be followed by protein data. This is just tying your shoes. And the reason why I am, sorry, the saying is dotting your I's and crossing your T's, right? If you see a difference in RNA, you must confirm that the protein changes there too, because that's not always true. And it is. So they did their due diligence here. So heart cells are making more of this mystery protein when they're exposed to insulin. So what is this protein? It is a cell adhesion molecule. This is a protein that cells need to stick to one another. It is an immune signaler that is upregulated in heart cells by insulin. So this protein makes the heart cell more sticky to immune cells. That's what this protein does. So very mysterious. That's not expecting the immune system to come up in this story in this particular way, which is very, very interesting. I feel like this is more important than the Diet Coke thing. Perhaps this, perhaps antibiotics, or I guess you might mean to mention antibodies, could be the next blockbuster drug. Bandrick, you're getting it. This is the lead that is buried by the Reddit comments, right? There's something interesting here. And no one is talking about it on Reddit because they don't care and they don't read the paper. Could this immune response activate by insulin because either consuming things open to the body to bacteria or because bacteria themselves have sugar and would make the insulin response happen? I think it's not worth hypothesizing further about what the nature or the evolutionary history of that relationship is, because immune signaling is complicated and metabolism is complicated. So I think a lot of biologists just shrug their shoulders and go, okay, I mean, they're related. Everything is related to the immune system and the immune system is related to everything. So I guess I'm not surprised that there's also this connection. So we have more details now. The mechanism is more clear. Aspartame into insulin, into this mystery protein, into heart plaques. Although this is still, raising more questions, right? Like now we're getting into the part of the paper that chat feels kind of good, right? This is kind of interesting, right? Like there's stuff here that is interesting and that I like, right? This entire paper isn't trash. Some of it is actually kind of cool. So here's a schematic for how this receptor functions, right? So there's this receptor here. So this is the heart cells, right? These flat cells. This is the heart. And this is a circulating monocyte. So this is a kind of or less differentiated immune cell that gives rise to a macrophage when the conditions are right. And so floating monocytes that are circulating within the heart, if they stick to this receptor, CX3CL1, that's our heart receptor, the monocyte has a receptor, CX3CR1. This is the cognate receptor, so it's the other receptor that binds to this receptor. This actually triggers a process by which the monocyte is pulled through the heart tissue and becomes a macrophage, and specifically, a specific kind of macrophage. In this case, is the M1, and this M1 macrophage is a pro-inflammatory macrophage that makes these inflammatory compounds. So now we're cooking. Right now we're cooking. We're cooking, dude. We're cooking now. Now we're getting into some actual interesting biology territory. So the researchers want to ask, so this is our hypothesis. Maybe insulin asks the heart cell to make more of this receptor, which makes it easier for these circulating monocytes to stick and become macrophages that do immune signaling, and that causes heart plaques, because that connection is a lot easier to connect. And so there's this very cool experiment that they do where they have a chamber and they grow heart cells on the bottom, and then they flow in circulating monocytes, and not all the monocytes will stick, but there are going to be a number of monocytes that stick to this, and then we can count how many monocytes stick, right? So does insulin help heart cells capture monocytes and then maybe force them into becoming macrophages? So that's cool. This is a great experiment. This is so cool. If this is our hypothesis that insulin causes this receptor to be made, which pulls the monocyte, makes it into a macrophage, this artificial system is a very, very cool way to test that hypothesis. I love this experiment. It's super cool. And so let's look at that data. So we are looking at fluorescent molecules for monocytes. So when you see green, that is a monocyte, and it is sticking to an aorta cell. So you flow the monocytes over the heart cells, and then you label the monocytes with a monocyte-specific label, and then you just take a picture. So let me explain how to read this. The green represents a monocyte, one immune cell who is destined to become a macrophage. That's what this dye is, calcine AM. I don't really know what the details of this dye, but apparently this dyes monocytes. So vehicle-treated heart cells get no active molecule. They're just heart cells, and then you flow over the monocytes. Insulin, this one is obvious. This is the aorta cells treated with insulin, and then you flow over the monocytes. Scramble, so this is an RNA that is inhibitory against a random target. This is an RNA that is scrambled up, and this is an important control. shRNA, this is an inhibitory RNA against the receptor on the monocyte. So this is removing this connection point right here. And the reason why they do this is to see if they can remove, like if this is the particular interaction, right? So this shRNA, that is breaking the connection between the monocyte and the heart cell. And then shRNA plus insulin, right? Just to check if this is mechanistically consistent. So chat, what can we conclude here? What is the actual result here? Is the plot twist the paper is secretly good? I mean, Clockwork, some of it is. Some of it is unironically interesting. Yeah, as BLN is saying. Some of it is pretty good, actually. CXCR1, also known as fractalkine receptor. Yeah, fractalkine is an amazing name for a protein. It's cool as hell. So chat, look at this data and interpret it. What is this saying about the effect of insulin on the stickiness of the heart cells for immune cells? Insulin alone looks the most activated. Exactly. Insulin looks like it makes monocytes really sticky onto the heart cells. So that's cool. Insulin does impact the amount of immune cells reacting. Yeah, exactly. And that's not nothing, right? This, to me, is why this is a Cell paper. Like, the finding that insulin is activating, or sorry, at this point, I'm not going to give the authors too much credit. The finding that the insulin treatment can make the heart stickier, or sorry, heart cells, we haven't proven this in an organism, can make the heart cells stickier to immune cells is already a very, very interesting finding. And that's unironically very cool. I love that. That's neat as hell. So if we look at this model, we can see that when you add insulin here, that these circulating immune cells get attached to the heart cell at a higher rate. And here is the actual quantified data. So number of cells per field. When there's no treatment at all, you don't get a lot of monocytes. You add that insulin, those heart cells get really sticky for immune cells. When you add the scramble, it's about the same, right? There's no statistical difference between this bar and this bar. Which is okay because, again, that scramble is a random piece of inhibitory RNA. It doesn't actually inhibit anything. When you add the target, when you try to break the connection between the monocyte, or sorry, when you try to break the connection that you think the monocyte and the heart cell has, then that goes way down. So we've correctly identified that those receptors are at play. And then when you add back that insulin, you don't save that, right? If you break the macrophage, sorry, if you break the monocyte, insulin doesn't save it because insulin doesn't do anything predicted to the monocyte. This is a really, really elegant experiment. We've identified the exact nature by which this immune cell and this heart cell are acting. Like, this is true. We've proven that this connection between monocyte and heart cell is triggered by insulin. And this set of experiments is designed actually beautifully with good controls. And I love that. I unironically love that. I think that's very cool. This should be the main focus of the paper, not the aspartame smoke and mirrors. I agree, Mandrake. This is the cool part. You didn't have to lie. I'm not going to say lie. That's too strong. You didn't have to be misleading about aspartame in the introduction when this is such a strong finding itself. It's crazy. It makes me so sad. Again, I'm not mad, I'm disappointed. I'm not mad, I'm disappointed. Is there an amount of insulin that has to be in the blood before the impact starts? Not tested in this paper. We don't know that. Here's some SEM, scanning electron microscopy images, comparing the texture of the aortic wall of mice that were treated with nothing versus aspartame. And when you zoom in, you can kind of see that the actual texture of the heart tissue between the ApoE mice, like you get a lot more of these folds, and then the aspartame mice are a lot flatter. I don't really know what that means because I'm not like a heart guy, so I'm not going to speculate. But what's that we see? What's that we see in this little square? That's a little monocyte. Isn't that cool? That's so cool, man. You zoom in, you actually take a picture of the aorta. In the aspartame mice, you can see the monocyte actually attaching there. That's a beautiful little follow-up to this artificial flow experiment. So we can see that there's real attachment in an actual animal. Again, a very artificial animal eating a very artificial diet, but it is there. It is there. That's why I can't get the idea of editorial malarkey out of my head. Editors force now. I don't know if it's the editors. I don't know who to blame here, but whatever, this product came out very aspartame focused for some reason, and I think that's not necessary. Not necessary at all. So, are these macrophages inflammatory, right? We predict that they're inflammatory because we kind of understand how the system works in a vacuum, and it looks like they do, right? Like the CXCL1 triggered mice, those macrophages, sorry, when you, I think this is isolated cells, I might be wrong, but I think this is isolated cells. When you isolate cells from the mouse and then you activate their CX3CL1 receptors, you actually do find that they do release inflammatory cytokines like TNF-alpha, IL-6, right? These macrophages are of the angrier variety. And so we know that angry inflammation can lead to plaques. So there's a story here, and it's an interesting story. So here is the results so far. And so Clockwork, if you're back in, here's where you can catch up. Mice that don't have this fat, this lipid transport protein, if they eat through their diet over 12 weeks, a clinically relevant amount of aspartame, they do have worse outcomes for the heart. Again, this is a highly artificial system. So it says nothing about human health. Is this mediated through insulin? Potentially, because aspartame consumption is sufficient to spike insulin on its own. It happens that aspartame can spike insulin in monkeys, although we kind of already knew that in humans, so I don't really know why they decided to show the monkey results, maybe to make their results seem more important. And then we ask the question, is insulin sufficient in spiking heart plaques? The answer is yes in these mice. You just give the mice insulin, they do get heart plaques. And if you remove the pancreas, aspartame doesn't give heart plaques anymore. Not remove the pancreas, but poison the pancreas. And so what's the mechanism behind here? We have a very elegant story where aspartame into insulin, into this heart receptor, which increases monocyte activation, adhesion, sorry. And then those monocytes then become macrophages that then become inflammation that then give rise to plaques. The next question that we should ask here, is this a real causative relationship, right? Like we're always tunneling in. It's like a, what is it? Those Russian nesting dolls of like, are these connections actually real? And so chat, is this evidence that this is how aspartame creates plaques, right? This is the story that the authors want you to understand. Is there a weak link here? If you're following the story, this is all the information we have. Is this a strong story to tell? Is there a weak link here? What do you think, chat? Wait, is that why artificial sweeteners are just as bad for you as sugar items? No. Let's not go too far here, okay? I'm being very careful and nuanced about what we should and should not take away from this paper. That's why I've been very careful to be like, this is going to be a very nuanced approach to understanding aspartame. So I've said nothing about human health. This is all in a mouse, and I'm going through every detail of this paper to make that connection, to give you the tools to make that connection for yourself, right? Does sugar-based insulin spikes cause the same thing? Yeah, that's a really good question, right? We don't know that because this paper didn't test that, right? Differentiation, has that been checked? That's a great point. We don't know if the monocyte adhesion equals macrophage differentiation. We don't know that. And Joel, you've got, I mean, everyone else's answers are correct as well, but Joel, you've got the answer that I'm thinking of. We have not proven that the inflammation from these macrophages leads to plaques. That is correct. That is what I'm looking for. So again, the CXCL3 activation does appear to be more inflammatory. Does that mean aspartame causes macrophages to hurt the heart? That's the connection that's not clear. This is a correlation, as Joel has pointed out here. I feel like this could validate the fractalkine receptor as a drug target. Yeah, there's something to be learned here, right? There's something to be learned here. Okay. So, in order to dig deeper into the causation here, we have a very cool genetic engineering bit. And so I've been teasing a genetic engineering 101 stream at some point. Here's a little taste for one of the techniques. This is called the Cree-lock system. This is something that I've gone over before. It's actually, like, when I learned this in graduate school, it's really hard. I'm going to try to test my teaching ability because hopefully I'll be able to explain this to you where it is comprehensible. So you have Papa Mouse, and Papa Mouse has a genetic perturbation. In Papa Mouse, we have a gene of interest. In our case, this is going to be, actually, I don't remember what this gene is, but let's just learn how the system works first. Oh, this is going to be the macrophage receptor, right? But this works for any gene of interest. In Papa Mouse, you have a gene of interest, and we flank it on both sides with a gene called LOXP. This is not relevant to you right now, but Mama Mouse has a specific gene called Cree recombinase, and this enzyme that this gene codes for is capable of snipping the genome at LOXP sites. So if you have a mouse that has both Cree recombinase and LOXP, you can delete a gene. And so in Mama Mouse, this enzyme is controlled by a gene that is cell type specific. So if you, say, for example, wanted to knock out a gene in only the macrophage, what you can do is you can get Mama Mouse, you can engineer Mama Mouse to link up the Cree recombinase enzyme with a macrophage only gene. Okay? So when Papa Mouse and Mama Mouse have a baby, that baby inherits both of these genes. And so the gene from Mama Mouse is destroying the gene from Papa Mouse. So the conclusion is that the baby mouse does not have the gene of interest in a specific cell type. So what we're about to see is that we are going to knock out the heart receptor in the macrophage only. And that is going to be a very delicious experiment to look at because that's causation. So I am going to take a poll from chat to just see if you understand the vibe of what this next experiment is going to be. It's complicated. It's complicated, and it took me quite a while in graduate school to wrap my head around. So I'm going to put up a poll. I've closed my own stream, which is a total mistake. So let me go ahead and set that up. Poll. Do we understand the basics of Cree recombinase engineering? Because I don't want to move on until we're like 80% in agreement with where we're at right now. Because this is a very cool genetic engineering technique. I love this technique so much. It's so good. It comes up all the time. It's a classic. I assume the deleted fractal kind from macrophages, so it can't dock to the receptor. Exactly. And we're going to see if aspartame, when you break the macrophage, does aspartame still cause heart disease? What cell type specific promoter gene do? So this is a genetic regulatory element. So this is a piece of the DNA that is activated only in a specific cell, right? So cells, you have all sorts of different cells. What makes your cells different? Well, each cell that you make, a neuron is going to make different proteins than the heart cells. And why is that? There are certain genes that are turned on in the neuron that are not turned on in the heart. So we take the part of the gene that regulates whether or not the gene is on or off, and then we put that Cree recombinase at the end of that. So for our Mama Mouse has a gene that turns on only in macrophages. So we can link up an enzyme that destroys our gene of interest to it. Macrophage broke, understandable, have a nice day. Yes, Sierra Smith, that's a very good simplification. Mom has gene cutter, dad has gene. LOXP says snip here, baby mouse has snip genes. That's a perfect recapitulation of what this genetic engineering system is meaning to do. So we are breaking the macrophage. We are breaking only the macrophage in an animal. Only the macrophages are going to be broken here. And I hope that's a little more clear. So it looks like we're about 64% yes. Okay, I think I understand it. Okay. I'll say it one more time, although Sierra Smith's simplified explanation is perfect. Mom has the tool that breaks the gene of interest only in the cell type that we're interested in. Because if you don't do that, then you have all these covariables, right? Like it's annoying. Like if you knocked out the receptor in every cell, then it's just like, oh God, the correlations that you would have to unpack are too much. But this is a beautiful experiment where you only knock out the receptor in the cell type that you care about. Okay. I think I'll go ahead and end the poll there. It would also allow us to see if other cells might react to those receptors for some odd reason. Exactly. So if we still see an effect, then aspartame is doing something else to some other cell type. Macrophage is still viable despite some level of brokenness, or macrophage nuke. It's a good question. I didn't actually really think about that because despite making videos about macrophage all the time, I'm not actually that well acquainted with macrophage biology. So that's a good caveat to keep in mind, Clockwork. I don't know. So here is our data. So here's how to read this. In the aorta, so these are dissected aorta, and the red dots are the plaques. So we saw some of this data earlier. This is 4 weeks of an aspartame diet or no aspartame diet. And this is knocking out the macrophage receptor. Flox is the, you can think of it as Papa Mouse's child that did not mate with the engineered mama mouse. So this is you can think of this as a normal mouse. So when you see flox, you can substitute that in your head with normal macrophage for the most part. And then macrophage M-, this is where you have mama mouse mate with papa mouse, and it knocks out the receptor exactly in the macrophage. And so when you're on the aspartame diet for 4 weeks, this is how the aorta look. And then 12 weeks, this is how the aorta look. So what are we seeing here? What are we seeing here? Does this also work the other way around? It does. Like, do males have recombinase too? You can engineer either mama or papa. It was just easier for me to provide a concrete example, but I guess you could say parent 1, parent 2. I just think that, like, it's maybe easier to visualize how the experiment is done. So I want to take a look at, I'm going to ignore the 4 weeks one. That's not interesting. It just shows that there's no plaques at 4 weeks, more or less. Maybe in this condition, but not a lot. The plaques really pop off at 12 weeks. So let's take a look at these comparisons pairwise, right? So in the normal mouse, if you give them, so let's do this, chat. You can answer my question in sequence and we'll see how well this does with the chat delay, but I'll be patient. In the normal mouse, this column, these 2 columns, what is the effect of aspartame on heart plaques? What do we see? Normal mouse, quote unquote normal mouse. What do we see? Just describe that data to me. Remember that red equals plaques. Less plaques, comparing vehicle to APM, these 2 columns right here. What do we see here? In the normal macrophage. Macrophage working normally. Normal mouse, aspartame results in more plaques. Yes, a piece bone. Yeah, Alexandra, a slight increase in plaques, slightly larger amount of plaques. I agree. By eye, I can see that when you give this normal macrophage mouse aspartame, you get more red. Absolutely. Normalize calling things wild type. It's not technically wild type though. I'll call a normal mouse because wild type is, normal mouse is a simplification. Wild type is technically not even true because it's flox. It's just, I think neither definition is great, Clockwork. And wild type might get people confused, just because I know I have like non-biology people in the chat. Okay, but what about when you break the macrophage receptor that's supposed to enable it to attach to the heart? Now let's compare vehicle to aspartame. What do we see? What do we see, chat? Just looking at their aorta. You break the receptor that the macrophage monocyte is supposed to be using to attach to the heart. Does aspartame cause heart disease here? It's very similar. M knockout looks like the best for having these plaques. About the same. Yeah. Yeah, with the broken macrophage, they both have about the same amount, which is much less than either of the normal ones. Roughly the same to me. Less plaques on both. So what does this say? This says that there is an actual causative relationship between the macrophage receptor and aspartame. And this is fantastic. So aspartame, whatever effect aspartame is having in these mice, it needs this receptor in the macrophage to damage the heart. And that's incredible. That is so interesting. So I'm wondering if anything's missing from this. Is there any part of the story we haven't uncovered yet? So let's review. In this artificial mouse lacking this lipid thing, so completely artificial system, they drink or eat a certain level of aspartame that is somewhat clinically relevant, they get heart plaques. Is this effect mediated through insulin? Probably. What is insulin doing? Insulin might be increasing receptors on the heart that attract immune cells and cause them to become macrophages. But there's still a part missing, and I think a chatter had said earlier, we don't know. So we know that the receptor is required. The monocyte receptor is required, but we don't know if inflammation leads to plaques in this system. But the part that is confirmed here, the causative part, is that there's something happening with the macrophage. That's real. We've proven that. That's real. That's amazing. That we've just went from consuming aspartame to having a pretty good experiment show that the macrophage is involved with heart disease through insulin, through aspartame. But again, I want to emphasize this for anyone who just came in. I've said nothing about human health. And that is on purpose because we haven't touched a human in this study, right? But it's really, really interesting. I want to know whether insulin spike from eating regular sugar would have the same effect as spike from aspartame. So it looks like whether or not these mice got sugar or aspartame, their insulin spike was the same, but we don't have the data to see if their heart disease is the same. That's a key experiment that we would need to do to gather some level of clinical relevance, but we don't have that. It's a good question though. So these are the conclusions that I'm drawing here, and I've separated them into two categories. One, we have the health implications, and then the other, we have the biology implications, and these are different. So, first conclusions, and chat, let's do this together, for those of you who have stuck along with me for the entire stream. What can we say about aspartame's effect on humans? What can you say from this paper? Is there something that we can say about the effect of aspartame on humans? Nothing so far, nothing. That's what chat is saying, nothing. We can say nothing, nada. Yes, thank you so much. Not the actual focus of this paper. We have no idea, right? We have no idea what the paper is saying about humans. Can aspartame exacerbate heart conditions? We'll say this broadly, right? Broadly. Is there a world where aspartame exacerbate heart conditions? There's a suggestion, maybe. Maybe need more evidence. Maybe. Possibly. Chat, you're doing so good. You're doing so good. Maybe, depending on how clinically relevant the ApoE mice really are. So if you say yes or if you say maybe, I would agree. I would say that the only wrong answer is no, because that's kind of like ignoring the whole paper, right? And this is the delicious nuance, right? This is what makes this paper so fun to read, is that like, it's not entirely clear, right? Like in this artificial mouse, I think it's not arguable. I think the evidence speaks for itself. In this artificial mouse, in this artificial system, aspartame causes heart disease, or sorry, exacerbates heart disease, because again, these mice are eating high-fat, high-cholesterol diets. Is aspartame worse for the heart than sugar? Is aspartame worse for the heart than sugar? Do we know that from this paper? Was there anything in this paper that suggests that aspartame is worse for the heart than sugar? Not nearly enough data to say anything. Unknown, no idea, was not covered in the study, no evidence at all. Thank you very much, chat. Not addressed in the paper. Thank you. Oh, chat, you're so good. I'm so happy. I'm so shrug, exactly, not demonstrated. I'm so happy. Doesn't compare anything with the sugar group, and that's what the Redditors should be complaining about, right? All this complaining, there's an artificial mouse, whatever, that's not really a problem. The problem is that there's no experiment that actually addresses human health in any relevant field. Wasn't inspected. Yeah, this is a good chat. Y'all are smart. Y'all are smart. I will use this stream as evidence that I can create an environment where the public can read intelligently a real piece of scientific literature and come to the same conclusions as someone with a graduate degree. And that is why I am very proud of you, chat. Do you like us more than Reddit? Oh, so much. You're not even in the same league. Big brain. I if nothing, like the thing that I am most proud of in terms of the magnitude of like dopamine that my brain gets is not my 4 million YouTube views. Although that is very nice and very fun, but like you can tell it in my voice. I am so hyped that you are thinking at the level of a research scientist, and not all of you have research degrees, because biology is accessible. You just need someone to explain what the terms mean. But you have the brains to figure this out. Anybody can do this as long as they remain humble, acknowledge their background, and learn what these experiments mean. It's not like this is why I think science is for everybody, right? Anybody can do science. Whether or not you have the time, upkeep, discipline to do it professionally, that's a different story. But anybody can enjoy science. And the thing that you have to do is not what Redditors do, which is just to read the title, but just read the paper. And you might not understand it, and that's okay. Papers are hard. You need an expert to decode a lot of this for you. But I just want chat to appreciate you have the brain to comprehend science as long as it has been de-jargonified. As long as it has been translated in plain terms, you can make scientific conclusions just as well as I can. And I love that. That's amazing. And you should be very proud of yourselves. And I'm very happy. So I have a different conclusion section about biology. And this is the challenge mode, because this is where the nuance is, right? The question of like, are there health implications? That one, like, I'm glad we're on the same page there. But this one is challenge mode. Like, you've completed the normal game. This is new game plus. So can aspartame contribute to heart disease? Parentheses biology version. We'll say I already spoiled this. Yes, in ApoE mice eating a high-fat, high-cholesterol diet. This is where the caveats are, right? So how does aspartame contribute to heart disease? This is more like memory stuff, so if you don't remember, I'm just going to fill this in at this point. In ApoE mice, aspartame causes an insulin spike. This insulin spike leads to heart damage. We saw that in the paper. This insulin spike can force monocytes to differentiate into macrophages. We didn't actually test the differentiation part. At least I didn't cover it. Maybe they did in the paper, I don't remember. The macrophages need this receptor to bind to the aorta cells and cause aspartame-induced damage. That is true. Whether or not the details are there, the absolute grain of truth that we can pull from this paper is that aspartame is causing the macrophages to do something that causes heart disease in these artificial mice. Insulin spike via unknown mechanism. The mechanism is hypothesized. There's actually, I don't know if you were here for the beginning of the stream, but the act of eating itself, the act of putting food in your mouth, even before your blood sugar levels change, is sufficient to cause insulin spiking. So how the macrophage is causing the damage is not yet fully understood, leaves it open to another paper. Why only in ApoE mice? How does ApoE protect the heart in the context? So we've only looked at ApoE mice, and this is a major complaint that Reddit has. And to be fair to Reddit, I think they should have done the wild type too. I think that the results here are cool enough to be published to somewhere, but I think that for Cell, you probably should have had the wild type too. For Cell, dude, one of the top 3 journals in biology ever, your career, if you publish as a graduate student in Cell as first paper author, your career is set. That Cell, you didn't do a wild type control? Like, that hurts me. But I'm left wondering, if this doesn't happen in a normal mouse, what's ApoE doing? I don't know. Well, how is ApoE protecting people from this effect if this doesn't happen in wild type? Wild type, like they grab actual wild mice. Yeah, Clockwork had mentioned this earlier, that wild type, sorry, it's jargon from my field. Wild type basically means a normal mouse, non-genetically modified. Yes. So we've touched upon this in the previous slide, but this is really important. This is a really important nuance that, again, a lot of Redditors missed because they got caught up with the typical complaints about genetically modified organisms, and they just say that as buzz terms because that's easy to pick on papers for not doing wild type. But in reality, there are some good reasons not to do wild type non-genetically modified mice. But there's no reason why they couldn't have done a set with just normal sugar, right? That sounds almost the level of deceit, right? Like, yes, aspartame can cause this in this artificial diet, in this artificial system. But what about sugar, right? Sugar spikes insulin too, and it seems irresponsible to not test sucrose in a lot of these experiments. Oh man, this thing didn't... Okay, whatever. Okay, so here are my pros and cons. I meant to have popped this up individually, so you're just gonna have to deal with this mountain of text. I will read it out though. Pros: some really beautiful molecular biology, very elegant, breaking a thing, doing the right controls. The last half of the paper is actually kind of nice. A lot of work went into this. SEM, that's a very expensive technique to image the cell surface. A lot of graduate students, there are a lot of experiments in this paper, right? It is worthy of being Cell on the merit of a lot of stuff happened in this paper, and Cell likes when you do a lot of stuff. There's an interesting finding that aspartame can, caveat, elicit an immune reaction that damages the heart through insulin, although we don't know if sugar does the exact same thing. The molecular results is probably why this is in Cell. It's a potential new therapeutic target, right? This paper discovered a new thing, as Chat has correctly identified, a new tempting drug target for pharmaceutical companies to maybe try and fix to address heart disease, right? Even if it has nothing to do with aspartame. Maybe to reduce atherosclerosis, you stop the heart cells from binding immune cells. That's valuable information. That's really interesting. And it's not like everything in this paper is weak. The strongest result in this relationship is between insulin, inflammatory cells, I'll say the macrophage and heart disease. So it really shouldn't be inflammation. Inflammation was not really that important in this paper. It should be insulin, macrophages, and heart disease. That's the strongest result here. And that, I think, is pretty rock solid. How does that impact their immune response capabilities, though? It's trade-offs, right? Every time you introduce a biological modification to your body, you're taking a trade-off. You're making the bet that you don't need that receptor, and that you will overall live longer and healthier by taking care of your heart versus nerfing your immune system. Medicine is tricky, I'll put it that way. Cons. Unnecessarily shady writing. If you've been here at the beginning, and if you haven't, please go watch the introduction to the stream, because there's some absolutely crazy writing in the introduction that I'm appalled that this made it through peer review. Shame on peer review for not clamping down on honestly dishonest use of citations. This paper is unnecessarily provocative. It can stand on the merits of being a mechanism paper, but I think maybe this wouldn't be in Cell if they just focused on mechanism. No wild-type mouse control. Again, you have to have a reason to have wild-type mice, and it's annoying that they didn't have wild-type mice, and I don't like that there's no wild-type mice, but for certain experiments, this is actually okay in my opinion. They should not have ignored the elephant in the room. They said that they were doing ApoE mice in like the beginning of the paper, and then the next time they talked about ApoE was in their conclusions, where they were like, oh, we have to acknowledge that this has limited clinical relevance. When, as a scientist, if I see that you're acknowledging that ApoE is a caveat, I'm more inclined to trust you, right? I'm more likely to think, oh, this is a group of scientists that have high integrity, that they want me as an intelligent reader to be aware of the caveats of their paper. If you say up front, hey, this is only true for heart disease mice, I'm more willing to go, okay, this is true for heart disease mice, and I'm more willing to trust you. But when you just kind of ignore the elephant in the room about your mouse model, I'm like, bro, like this is not a language thing. Like even if this were written in a different language first, you would still talk about ApoE and the caveats in the beginning of the paper to establish that reader trust. And I don't like that they don't really do that in the paper. I found the monkey experiments to be like pretty random. Maybe I didn't read carefully enough, but I found myself being like, why are we looking at monkeys again? Like I didn't feel like we had a good justification for it. Lacking sugar matches in certain places. This is really annoying, right? This is, to me, worse than the wild-type mouse thing. Like, not having a sugar match is annoying. And I think that it didn't have to be an aspartame paper. And I'll get into how I would do the paper in a future slide. And so, to me, I don't want to call them lying, but I would say it's bordering on deceit, depending on your interpretation. Those are very strong words coming out of me, right? But one could argue that the practice of not being upfront with your ApoE model, the practice of misquoting a citation, a citation that on its own kind of sucks to begin with, it just sucks. That part of the paper sucks. And then some neutral things. ApoE mice, they were subjected to high-fat, high-cholesterol diets in almost every experiment, and that's kind of annoying, but it's not crazy, right? Like, as Guy had correctly pointed out, this is a targeted research question, so your experiment should be targeted. It's not necessarily a bad thing that they didn't have every single control. Disease models exist for a reason, right? You gotta study the thing that has the disease if what you want to study is the disease. Because, as we've seen in human studies, if you just give normal people aspartame, they're generally pretty fine. So of course you need to artificially inflate the disease to see if it worsens the disease, right? It's not like this paper has zero clinical relevance. It's just that it hasn't been proven yet. And so I'm trying to give like the research paper, like the research authors, the benefit of a doubt. Maybe they wanted to talk about aspartame because it's a little more eye-catching, because it is a little more inflammatory. And maybe it is more deserving to be in Cell if the results are a little more splashy. But I respect the journal Cell a lot, and I'm honestly kind of shocked that this made it through. What's minus? So that is a double knockout. So it's a gene that, yeah, exactly, Mandrake. It's a gene that's been totally yeeted. So ApoE totally yeeted mice. So those mice do not make this lipid transport protein. Sorry, that's a lot. It's another bit of jargon. I sometimes forget what's jargon, what's not. So how would I fix this paper? Because again, there's like stuff in this paper that is really, really cool. The way that I would have done this is quite different. I'll put it that way. So how would I fix this paper? So first, let's look at the structure. Let's look from a writing perspective, how this paper is currently structured. So their beginning argument, the thing that they say to set you into the correct mood to read this paper is that aspartame is bad, or that there is reason to believe that aspartame is bad. Okay, I have to do this. Sorry. This like didn't animate well, so I kind of have to move this manually. Aspartame is bad. Aspartame spikes insulin levels. We kind of knew that from human trials. Insulin is sufficient to create heart disease, heart plaques. That's their results that they showed in their mouse. Insulin is forcing macrophage differentiation. This is more implied, not really proven as far as I could tell, but I could be wrong on that. Macrophage receptor is required for insulin-mediated heart damage. This is the strongest result that is very cool. You need that macrophage receptor. Aspartame is doing something to macrophages, and you need that specific receptor to cause heart damage in this model. Ergo, aspartame is potentially leading to heart disease through insulin and macrophages. So I think this sucks because aspartame is not the only thing that spikes insulin. The act of eating spikes insulin. So what the hell are we actually supposed to learn from this paper? Right? Like this is kind of flimsy, right? This argument structure, the way that this argument is laid out, I hope my chat can appreciate, is unconvincing to me, at least. This doesn't convince me. Insulin bad, that is kind of what the authors are subtly trying to get you to lean into. But again, I need to remind chat, insulin spiking is a very normal thing that happens in the body because you need insulin to draw in the blood sugar into your actual cells, right? Insulin is supposed to spike. That's just what happens when you eat food. It's when insulin becomes unresponsive, when your cells ignore insulin, that's when you get diabetes and a bunch of problems. So I don't like this structure. I think I can do a better job. Oh, you know what would have been better? I should have blinded chat. I should have given you two structures, and I would have... next time. But here's my first attempt. So I rewrote this structure 2 times because I liked my first attempt, but it wasn't perfect for me. So I'm going to show you my thought process and how I would think of this paper. So I have to do this on PowerPoint instead. Here's how I would open here. The mechanism by which heart plaques form is unclear. We don't know exactly all the details by which heart plaques form. That's pretty reasonable. Inflammatory signaling may be responsible for heart plaques. I think that's, I'm not adding new information, okay? Insulin is associated with inflammation. Again, I'm using the same background, just a different order, and you can get a sense for what our stories are going to be. Insulin is sufficient to create heart plaques. I'm citing the same data that their paper is citing. This is the circulating insulin experiment. Insulin is forcing macrophage differentiation. Again, implied, not really proven, but implied. Macrophage receptor required for insulin-mediated heart damage. And then dietary regulation of insulin is sufficient for this effect if you added a sucrose element, right? Because I'm sure that if what the authors genuinely believe that insulin is the problem, do sucrose too. Do sucrose too. Do it. Sucrose spikes insulin. If sucrose spikes insulin and aspartame spikes insulin, just eating sugar should cause that heart damage as well. And then those results get, put into context, right? Because we already know that like dietary things are important for heart disease. But you can kind of tell that like there's this mysterious omission for some reason, because I don't know the authors, but I don't like that there's this omission. And then I would first do sucrose, and then I would say it doesn't have to be sugar. So we associate with sugar with heart disease. That's not controversial. And then the way that I would tie in the aspartame story is that it's insulin, right? It's insulin that is sufficient. So something that causes an insulin spike that doesn't get metabolized the same way can also cause heart damage. So ergo, a new target for this cardiovascular disease can help this problem, right? And you can see, chat, like, or what I hope you can see, and my hope is that I have communicated it properly, is that I, in my revision of this story structure, am emphasizing what I think is the best result, which is the macrophage targeting. I mentioned aspartame one time here, and to me, my structure feels a lot more natural, a lot less forced than this aspartame is bad thing. And again, I don't have a stake in this, right? Like, maybe aspartame is bad, maybe it's not. I don't really have a horse in this race. I don't care. But I find that the insistence that aspartame is bad, it, ironically enough, tastes artificial here. It almost seems like they set out to prove aspartame is bad. I don't want to like imply deceit by the authors, but I will say that it is very leading, and I think that is fair. It's fair. It's not fair to say, you know, oh, they're paid by Big Sugar or whatever. That's not fair. We don't know. Let's not make those assumptions. But what they are doing is they are not letting me make my own conclusions from their writing. I don't feel free in their paper. I feel very caged in. My sniffer doesn't go, the way that you know a paper is written well is that when you're reading the paper, they answer your questions the order that you have them, right? Beautiful papers in Nature and Cell. You read a result and you go, ooh, I wonder if this is true. And then they test that. That's the most natural way. And this structure feels very forced to me, whereas I like mine more. But I actually don't fully love my own structure here either. I think I can do better. Okay. So here's my second attempt. Here's my revision of my order. So it starts the same. Sugar, mechanism by which heart plaques form is unclear. I move the sugar argument higher because sugar consumption is associated with inflammation, which is associated with heart disease. Okay, there's a connection there. Sustained sugar consumption is sufficient to worsen heart disease in this model. We don't know if that's true. At least I couldn't find results that compared aspartame to sucrose in all of their data. Sure, like for some of the data we have that sucrose control. I don't really see it in all of the controls, although I could be wrong here. I mean, I could just check real quick. Hold on, let me just see for the really exciting stuff if there were equivalent sucrose controls, because I just want to check that we're mostly in that. We're mostly in the, yeah, that's aspartame only. This is insulin only. Yeah, we don't really see... we see some sucrose controls in the monkey studies, which is interesting, but that's not causative. We don't see the aorta studies in the monkey. We only see the aorta studies in the mice. And I don't think we ever see... If they do have the sucrose, can somebody check the supplemental? Maybe I'm being careful here. If I'm crapping on them all day and night, I want to make sure that it's not somewhere in the supplemental. So the paper is in the comments, not the comments, the video description. So if somebody could help me out and check the supplemental for the aorta, if there are additional aorta data that have sucrose, and we can maybe talk about that. So, because I want to just double check that I'm not being unfair to them. But also, if they hid the sucrose stuff in the supplemental, that's still a reason to be mad. I'm still mad if they hid that stuff in the supplemental. I don't think that's good either. Because it's kind of like hiding away your dirty laundry in a way, and I don't like that. I don't think that should be true. So while somebody is helping me with the supplemental, I'm going to go ahead and tell you how I would structure this paper, right? So let's talk about sugar right away. Sugar associated with inflammation, which is associated with heart disease. Sustained sugar consumption is sufficient to worsen heart disease. They didn't do that in this paper, I think. Please check the supplemental if I'm wrong. But that is a more natural lead into talking about insulin. Because insulin happens after eating sugar. Does insulin cause heart disease? So aspartame, so we know that sugar does, probably. And then you check aspartame. So aspartame is mostly inert. It doesn't get broken down the same way that sugar does, but it still spikes insulin. Does sustained aspartame consumption cause heart disease? And then we have that data because that's what we have the model for. Insulin is sufficient, so we know that aspartame can do it. What about pure insulin? So that also creates heart plaques. We have that data. And then you have the rest of the macrophage stuff. And to me, like, this rollout is, to me, it feels a lot more honest. It feels a lot more natural. And you know, I might be blowing smoke up my own membrane, but I think I did a better job than they did. But insulin is a very, very good as a signaling molecule. Metabolism works multicellularly, thanks so that the signaling cascade is like the one insulin is responsible for. Yeah, and I think it's a trap to get too hung up on insulin here, which is why I think that prioritizing this finding is much more interesting, the macrophage finding. This is more like justification for finding the macrophage stuff. Like, all this is like the clues that lead to the macrophage stuff. But yeah. So I don't know if there's anybody in chat who's currently helping me, so I'm just going to quickly open the supplemental figure and just quickly check so that I am not being unfairly harsh about the plaques thing. Okay, we do actually see, again, hidden in the supplemental, which I'm super annoyed about. So let's just pull this up. Okay, so they did do the experiment that I am wanting, although they didn't do all of them. So let's make a last minute check here. Yeah, dude, all their sucrose stuff is in the supplemental. That's so annoying, man. Don't hide it. If you did it, just show it. There's no reason to oh, there's especially no reason to hide this stuff. Dude, what the actual heck? Okay, we're gonna have to make some last minute changes here. Why would you hide this? This is so dumb. Why would you hide this? Why would you hide this? Let's show this data. And we can live react to this data together. Okay. So this is from the supplemental. So they do the sucrose control. I don't know why they hide it. Because this is important information. What's supplemental? It is more research that they did that they felt didn't belong in the main story. But to me, this data is actually really good for them to have in the main body of the paper. Yeah, why would you hide this in the supplement? Thank you. Look, they did the sucrose control, and what they found was that sucrose doesn't have the same number of lesions. So by some metric, aspartame is actually kind of unique. That aspartame is causing the damage, and when you do sucrose... Now, like, I'm pulling from the supplemental, so I don't know if they did the equivalent. Like, there could still be some shady stuff here that I don't know about, because I didn't, like, read the text carefully enough. But, like, why wouldn't you if this is, like, good, honest data, why not have this in the main body? Because this is what people want to know, right? Like, is aspartame worse for you than sugar? Bang. There is your answer, kind of. Again, I didn't read the details on how they did this, so there could still be some shady things. But this data is hiding, and I don't know why, and it's insane. Are supplementals peer-reviewed? That's a really good question. I'm not a published author, so I'm not 100% familiar with every detail on publishing, although Mylan can attest to their own experience as a researcher. Yeah. But why would you hide this? This is crazy. This makes your case stronger, not weaker. There's no reason to hide that. There's other things about the parasympathetic nervous system that I ignored. That's not important for the overall conclusion of the story, but just out of pure transparency, like, there's a part of the story that I cut out for time that wasn't that cool to me. And that's about the nervous system, and I just didn't find it very compelling. Is there anything else that they hid that was in the supplemental? Let's just check. Gain and loss. I mean, they did a lot of work. I am very, like, it's not a half-baked paper in terms of the amount of work that goes in. I just hate how it was written. Single cell, DNA seq. This is more of that mechanism stuff. Okay, well, they didn't do the sucrose stuff with the macrophage part of the story, so that's kind of annoying. Yeah, that's kind of annoying. They didn't. So this is just seeing if aspartame or sucrose has an effect on heart damage, but they don't. They don't actually. I mean, you can kind of make the argument that you don't have to do the sucrose control because you show here that sucrose isn't damaging the heart more than not having sucrose. Yeah, I'm so confused as to why they show this in the supplemental. It's kind of driving me crazy. Histological immunofluorescence analysis of plaques, double knockout. It's fine. Okay, so let me walk back my criticism of the paper just a little bit. So they're not deceitful nefariously and not doing the sucrose at all. I just find it a very questionable scientific choice to hide such an interesting conclusion in the supplemental. Seems kind of weird. It's not that the sucrose did nothing, it's more like a delayed response. Pretty bizarre. I understand a little why they removed it from the paper. Delayed response, I don't really know about that. By 12 weeks, there's still a significant difference between sucrose and aspartame. Oh, I guess that's true, because you can't really compare apples to oranges. This difference is not really meaningful because there are covariables, right? Sucrose is broken down through one metabolic pathway, aspartame is broken down through another metabolic pathway. So it's hard to make a meaningful comparison between blue and red bars, sucrose and aspartame, but you can compare both to the vehicle. And yeah, sucrose does have an increased effect at 12 weeks. That's definitely true. I don't know. You're right, guy. Yeah, thank you for that. Thank you for that. Yeah, my chat is so correct. Y'all are so smart. That is absolutely true. Maybe that's why they removed it, because even though it looks like this is like panel B, I bought their Kool-Aid. I bought their aspartame. I bought in, and for that I am scientifically weak. But to me, this was shocking. But as you have all pointed out, C is less shocking. It looks like sucrose still has an effect, and comparing blue to red isn't really meaningful because they're so different. It's so weird how one half of this paper is sloppy and the other is super tightly shipped. Yeah, I mean, I don't know. Like, this is bizarre. Very bizarre. Okay, so let's move on. Did I finish covering that? Yeah. So that would be my structure. So now if you want to do a read along, I have a link here that I'm going to paste into chat, and we are going to read the reaction of the scientists. So I don't know if there's like a copyright on like science, like I don't know. I just like want to deal with copyrighted materials, so I'm just going to paste it in chat, and we are going to read together the expert opinions, because I think that is cool and interesting. Because I am very like I minored in rhetoric. I'm like in love with words. Like I think words are incredibly interesting to read, and we should read what people are saying. So we already looked at the Reddit take. We already seen that, in my opinion, Reddit ignored all the interesting parts of the paper and got bogged down in something that didn't really end up mattering. So let's go to the professional. So we'll start off with the media release from Cell. So this is the journal press release. So I'm just going to read it out loud. Sorry, there's a boring graphic on screen, but like I wasn't sure what copyright, whatever. From diet soda to zero sugar ice cream, artificial sweeteners have been touted as a guilt-free way to indulge our sweet tooth. However, new research publishing in the Cell Press journal Cell Metabolism on February 19th, again, super fresh paper, shows that aspartame, one of the most common sugar substitutes, may impact vascular health. The team of cardiovascular health experts and clinicians found that aspartame triggers increased insulin levels in animals, which in turn contributes to atherosclerosis, buildup of fatty plaque in arteries, which can lead to higher inflammation and an increase of risk of heart attacks and stroke over time. Okay, I mean, technically all true, not being straightforward with the fact that this is a genetically modified animal at the beginning, right? So again, it's like annoying that it's not upfront with the disclosure, right? The research was inspired by a can of diet soda during a project meeting. One of my students was sipping on this sugar-free drink, and I said, why don't you look into that? Recalls senior author Yihai Cao, who studies chronic diseases related to blood vessel disorders at the Karolinska Institute in Sweden. This is like the most, this is cringe. I I don't believe that happened. I mean, maybe it did. Maybe it did. Maybe the PI was like, "Oh, you're drinking a can of diet soda. Maybe you should study that." That seems too hokey for me as someone who had molecular biology research. You're usually piggybacking off of existing research, so this just feels like a very hokey story, and it's like a cute story, but I don't like buy it. But whatever. Like I can't say that they're lying. I'm not convinced. Previous research has linked the consumption of sugar substitutes to increased chronic disorders like cardiovascular disease and diabetes. However, the mechanisms involved were previously unexplored. Sure, I'm not a metabolism guy. I don't know. I didn't read the research, but I'm just going to take you at your word that there is research that links sugar substitutes to chronic disorders. Fine, I will give you that, although I can't say confidently that you're correct. And I want to model, chat, how you deal with uncertainty, right? You just say what you're uncertain about. I am very clear about where my expertise begins and where it ends. And so you can assess information and give it a confidence interval, right? And so here I say, okay, with high confidence error, right? I will agree with you, but because I'm not an expert in your field, my error bars for your knowledge is very wide, right? I'm ready to be wrong, or I'm ready for you to be proven wrong. But I'm also not being mean. I am taking you at your word because I owe you that much as someone reading your work, right? I'm giving you the benefit of a doubt, which you should. For the study, the researchers fed mice daily doses of food containing 0.15% aspartame for 12 weeks, an amount that corresponds to consuming about 3 cans of diet soda each day for humans. My calculations say 1/3 of a can, but I mean, this is within the like realm of the same calculation, right? Like 1/3 versus 3. I mean, yeah, that's 9 times, but we're in the ballpark of normal. Like we're not 10, 20, 30 times as much as that one Redditor had calculated, right? Like that's an order of magnitude off, whereas my calculation just might be different because I'm not a pharmacologist, right? I did a back of the hand calculation. Compared to mice without a sweetener infused diet, aspartame fed mice developed larger and more fatty plaques in their arteries and exhibited higher levels of inflammation, both of which are hallmarks of compromised cardiovascular health. Yeah, I would agree with that. When the team analyzed the mice's blood, they found a surge in insulin levels after aspartame entered their system. Correct? The team noted that this wasn't surprising a result, given that our mouths, intestines, and other tissue lined with sweetness detecting receptors that help guide insulin release. That's that circuit that I was talking about earlier. The very act of eating causes an insulin spike. But aspartame, 200 times sweeter than sugar, seemed to trick the receptors into releasing more insulin. I don't think that was in the paper, right? I don't remember seeing. Maybe I'm wrong. And I could be wrong again, because it's not like I had 3 days. I had 3 days and I did this in my downtime, right? I didn't have a ton of time to double check, but I don't remember a sugar comparison with insulin. I'm tabbing back through the paper now. In the monkeys, it was just about the same. Ooh, did the press team make a boo-boo? Did the press team... I'm not seeing that data, chat. Someone in chat can double check me. I am not seeing that data, and I don't think that was in the supplemental either. Well, okay, before I say that, let's check the supplemental one more time. Oh god, making me go to the freaking supplemental again. Jeez, just have it in your freaking paper, dude. This is plaques, this is more plaques, this is histology, this is... what is this? God, there's so much here. Maybe it's in the paper. Hold on. Chat, please. It's an open source paper. If someone could look at the real paper and give me a quick idea if they did insulin with sugar versus aspartame, and I will look at the supplemental. Chat, it's a great way for you to actually like look at the data yourselves and kind of tab through the paper. It's kind of a cool experience. So there's weight, body fat, glucose, lipid level, VO2 max, heat, UC, ViSo. I have no idea what these are. I think these are metabolic measures. Plaque area, insulin. This is with vehicle and aspartame, but no sugar. This is more plaque stuff, instability constant. I don't see anything in their supplemental so far. Plaque area, plaque, plaque. Insulin anywhere? Insulin enjoyers? Insulin check? Lesion, plaques, vessels, any insulin mention at all in the supplemental. This is RNA data. I don't see it. Plaque area, receptor mechanism stuff. I don't see it. Okay, I don't see it in the supplemental. I'll do a cursory glance at the actual data. Did they test sugar versus aspartame and insulin? Okay, they do. Okay, they do. That's fair. Okay, so if I'm going to be mean to them, I need to be appropriately mean to them. And fasting serum insulin is different between sucrose and aspartame in this mouse model. Okay. I'm going to peel it back. I'm gonna peel it back. Yeah. I could have also made a math mistake. That's also true. Okay. That is fair. Okay. I've double checked. I was surprised by that finding, but you know, we are trying our best, and if we make mistakes, we make mistakes. We checked that part is correct. Aspartame, although bringing up 200 times sweeter than sugar is annoying. If you read that part in the press release, the full statement is, but aspartame 200 times sweeter than sugar seem to trick the receptors into releasing more insulin. That is a hypothesis that is not tested. It's not the sweetness in this particular paper that is making an assumption based on background information that is not included in the paper, which can be potentially misleading. From this paper, the only thing that we can say is that aspartame did it more than sugar, which is fair according to the data of the paper. I don't know if it will replicate. I don't know if they lied in the paper, but if we are taking their for their word, that's a fine statement to make, albeit if you add in the 200 times sweeter than sugar, you are diverting your audience into a particular hypothesis, which I don't love. I don't love that. Okay. The researchers then demonstrated that the mice's elevated insulin level fueled the growth of fatty plaques in the mice's arteries, suggesting that the insulin may be the key link between aspartame and cardiovascular health. Next, they investigated how exactly elevated insulin levels lead to arterial plaque and identified an immune signal that is especially active under immune stimulation. Yep, that's all fine and good to me. Because blood flow through the artery is strong and robust, most chemicals would be quickly washed away as the heart pumps, said Sal. Surprisingly, not this particular immune signal. It stays glued to the surface of the inner lining of the blood vessels, and there it acts like bait, catching immune cells as they pass by. Yeah, that's a fine analogy to make. Many of these trapped immune cells are known to stoke blood vessel inflammation. However, when researchers eliminated this receptor from one of the immune cells in aspartame, the macrophage, the harmful plaques buildup didn't occur. Very true. This result points to this receptor's role in aspartame's effect on the arteries, says Cao. Yeah, I agree with that. Looking ahead, Cao and his team plan to verify their findings in humans. Cao also foresees this as a potential target for chronic conditions beyond cardiovascular disease, given that blood vessel inflammation is involved in stroke, arthritis, and diabetes. Artificial sweeteners have penetrated almost all kinds of foods, so we have to know the long-term health impact. Citation needed! I'm willing to believe you, Dr. Cao. I'm willing to believe you. I just need a little bit of proof, my guy. Just give me one link. I'm really willing to be on your side here. I just need a better citation than that one review, man. Like, yeah, man. It's a bummer, dude. My advisor said it best. You want to be on the side of the researcher. You never want to be adversarial. Like, I don't want to just trust you. But this statement, artificial sweeteners have penetrated almost all kinds of food. I need evidence. I need evidence. And you're not giving it to me, and it makes me sad. Okay, let's look at the expert reaction. So that was the official press release. It's fine. I was tripped up, but I was missing a part of the press release, which was fine, and my bad. I admit fault there. So Oliver Jones is a professor of chemistry at RMIT University in Melbourne, Australia. I have several concerns about this study. The authors claim that the consumption of aspartame by adults and children often exceeds those levels recommended by the FDA. This is extremely unlikely in my view. The FDA acceptable daily intake is 50 mg per body weight. I weigh 80 kilograms, so this means that the FDA-based safe dose for me is 400 mg or 4 grams of aspartame per day, every day for life. That's what I found in my back of the hand calculation for the mice. Given a diet drink contains about 200 mg, I would have to drink the equivalent of 20 cans to get this dose. A child of 40 kgs would have to drink 10 cans a day every day. Even then, the 50 mgs has a safety factor of 100 built in, right? So yeah, I mean, again, this is one expert disagreeing with another. I'm just going to stand on the sidelines and be like, okay, yeah, cool. Like, but the maths, right? Like this argument is more convincing to me because the math is mathing. The study design also has some issues. The main one is that the authors used a particular type of, oh my God, wait. That press release that Cell did they mention ApoE at all? Or did they just say mice? I think they just said animals because they did mice and monkeys. Cell press. No. Let me double check. Always want to be very careful. Did you mention mutation? Control F mutation. Control F ApoE. Okay, they did. No, they didn't. No, there's no mention of ApoE. There's no mention of mutant mice in the press release. Oh, the official press release does not give the caveat that this is a special mouse, and that hurts. Okay, so Oliver Jones does mention it, right? So Oliver Jones says, the main one is that the author used a particular type of lab mouse called ApoE, which is bred to be prone to heart disease. I agree. They also fed it a high-fat, high-cholesterol diet, which itself increases the risk of heart disease. I agree. This is a very artificial system. They also don't seem to have measured how much of the aspartame water... They also don't seem to have measured how much of the aspartame water the mice drank or the aspartame levels in the blood, so it is unknown what the mice actually received. This is true. I am personally not as offended by that measurement because this affects the error bars, not necessarily order of magnitude of the difference, though. So, like, while I agree it would have been nice to know how much circulating aspartame in there is, in the mice were, to me this doesn't ruin the paper, although I could be wrong. I'm open to being wrong on that point, but I don't see how that actually like helps. To my mind, the author's admission that feeding mice that are already genetically susceptible to heart disease with a high-fat, high-cholesterol diet that is known to cause heart disease diminishes clinical relevance is somewhat of an understatement, right? So the paper says that their caveats diminish clinical relevance, which is true. But it is also a very academic way to say, like, don't take this for anything serious, except do, because, we're getting mixed messages from the paper. Contrary to the paper's claims, it is quite established that aspartame doesn't stimulate glucose or insulin levels in humans. I mean, we did see those papers, and we also know that there are circuits that react to just eating, period. So I think it is more correct to say that that aspartame doesn't affect insulin dramatically differently than sucrose does, right? It's not worse for you, as far as I can tell. And maybe because I didn't read hundreds of aspartame papers, I Google scholared aspartame insulin, and I looked at a couple papers, and they seem to agree that aspartame, the act of eating is spiking insulin. I think, again, I'm not a metabolism guy, so I'm free to be proven wrong in that point. There's a lot of leeway here that I'm allowing the interpretation of the results because I am not an expert, right? Like, the things that I am confident in is the mechanism part, because that's my lane. I'm a cell and molecular biology guy. The macrophage stuff was cool, and I thought it was good. This stuff about connecting stuff to human health, this is not my lane. This is a doctor's lane. So I don't have anything to say to that. So maybe this doctor knows more than I do, although they're a professor of chemistry and not a doctor. So, I mean, I guess maybe their opinion is not inherently more valuable than mine. but whatever. Maybe they have more medical knowledge than I do. I don't know. Moving on. Aspartame is essentially just two common amino acids, aspartic acid and phenylalanine, joined together. In the gut, it is broken down to aspartic acid and phenylalanine. There's no reason to think that amino acids from aspartame would be worse than from any other source. I mean, yeah, but I think that is this is unnecessarily specific, and I don't think you needed to say that. Although I think that does help the average person feel a lot more at ease to know that aspartame is just two amino acids linked together, even though that's not proof of anything, right? You can have configurations of amino acids that are bad for you. But yeah, from a public health communication, fine, whatever, that's fine. The authors would appear to think that little work has been done on the safety testing in aspartame. This is just not true. All food ingredients are rigorously tested and safety assessed before they are approved of use. Aspartame is one of the most researched ingredients in the world. It's just that a lot of the data in safety assessments for regulatory approval, not the academic literature. And I think that's fair. Like I'm limited to what I can get on Google Scholar, so it's very possible that a lot of the safety literature is stuff that I don't have access to. Finally, even if aspartame did cause some increase in cardiovascular risk, which this paper does not prove, I agree with that statement, then the risk would likely be very small compared to things like high-fat, high-sugar diets, lack of exercise, etc. I agree with that as well. In short, I don't think this study gives us more reason to worry about the diet drinks or aspartame. Yeah, I agree with this. Like, they use a mouse that was eating terribly and genetically predisposed to heart disease. So in terms of your average human, probably pretty good to in my assessment. In my personal life, I'll say it this way because I don't give medical advice. This does not convince me to change my aspartame consuming habits. And I think that is ethical to say out loud and be consistent with my own thoughts and morals, I should say. Okay, next we have an actual medical person. Dr. Ian Musgrave is a senior lecturer in the Faculty of Medicine, School of Medicine Sciences within the discipline of pharmacology at University of Adelaide. Artificial sweeteners play a role in people's attempts to control their calorie intake and reduce weight. However, artificial sweeteners have come under attack for several false assertions about their health effects. However, a recent concern is that their sweetness may have an impact through the body's sensors for sweetness that causes inappropriate hormone responses. Yeah, that is what I've learned through reading this paper, that we have a sweetness detector that potentially causes insulin spikes. A new paper suggests that stimulation of the sweetness sensors may stimulate too high of a release of insulin, leading to adverse effect on blood vessels. However, it is unlikely to be of direct relevance to humans. This study was done in mice, which were genetically engineered to lack a key lipid transporter, then fed a high-calorie, high-fat diet to stimulate the formation of fatty plaques in the blood vessels. These mice were then fed a control solution of aspartame in a dose equivalent to 3 cans of aspartame a day. I guess I did my math wrong because this person is also saying 3 cans a day. And then their blood vessels were inspected for fatty plaque buildup. Aspartame-treated mice had more fatty plaques in their blood vessels, and the experiment suggested that their insulin signaling was disordered. I agree. While these experiments are elegant, the relevance of these experiments to humans is unclear. Genetically engineered mice on a diet specifically designed to accelerate plaque formation is unlikely to replicate the biology and dietary situation of most humans. Importantly, in the blood vessel experiments, the effects of an equivalently sweet dose sugar was not studied. On the blood vessel experiments, not on the insulin, but on the blood vessel experiments. Yeah, that reflects my finding as well. Nor the effect of the reduction in caloric intake by the amount of aspartame consumed. There are a lot of changing variables that I think were not addressed. While the study may have given us a new target for treating plaque buildup, in one of the body's inflammatory molecules, it does not suggest people should give up their artificially sweetened drinks. So Dr. Ian Musgrave, I'll just say right now, I agree. I find nothing problematic about that statement. That is consistent with my own feelings and thoughts about the paper. Okay, and then we have here, I'll just say that this one doesn't add anything to the conversation that, yeah, I don't have anything interesting to say about Dr. Yutang Wang's thoughts, but I do want to go to the last one. So if you're following along, go to the last paragraph. We're talking about Professor Mark L. Walkvist, AO, Emeritus Professor and Head of Medicine at Monash University and Monash Medical Center. The past president of the International Union of Nutritional Sciences. New findings about the biological effects of the dipeptide, a so-called, like a weird thing to be picky about, but okay. A so-called non-nutritive sweetener, aspartame, discovered by accident in 1965 by a chemist looking his finger, underscore important limitations in food and nutrition sciences as applied to health. The first is that the molecules like dipeptides would have little to no biological consequence or food safety concern, but controversy has dogged this and other substitutions of sugar since their first approvals decades ago. This was in 1983 for aspartame by the FDA in the US. confirmed in 2023 by IARC, International Agency for Research on Cancer, and the WHO found that there was limited evidence that could cause cancer, and that intake should not exceed 40 mg per kilogram body weight per day. In the meantime, evidence that its substitution for sugar in the prevention and management of obesity has been unconvincing, as for some similar substitutions. After all this time, convincing evidence from the Karolinska Institute in Stockholm with colleagues in China that aspartame can adversely affect arterial health by inflammatory damage is disturbing. We need to be clear that the sweetness recognition is one thing, and that energy caloric regulation is another. Receptors for sweetness occurs throughout the body. The idea that one effect was necessarily linked to another was flawed, and playing with sweetness to deal with energy metabolism has proven biologically fraught. We should stop the inappropriate use of sugar substitutes. And then we have a very neat little section here that says declared conflicts of interest. Mark is a past president of the International Union of Nutritional Sciences. So that's a little interesting. A little interesting. So I want to point that out, that it's difficult for the average person to navigate expert opinion, right? Like, you know, Mylan's here, who is a psychologist, and Mylan can talk all about how difficult it is for people to get information that is consistent with scientific reality. Because we have here a bunch of people with doctor in their title, and some of their opinions are different from one another, right? And so what does the average person think? Like, you know, there are experts on both sides. There are always experts on both sides, which is why there needs to be a space where the public can twofold. A, the public should have a mechanism in their education by which they actually care about what data say, right? Like, most people, they just want to hear what the expert says or what their favorite expert says and then go with that. And a lot of the time, that's an opinion that is already in line with what they want to believe. And that's human, that's natural. Part of why I really love this community so much is that you want to hear me yap for 3 hours about every minute detail, because in order to have, and because the truth is complicated, right? Because the truth is complicated, and you need experts to walk through a paper, and those pressers from some of those professors I am in agreement with. But because the truth is so complicated, there are going to be people who claim to be experts whose opinions are going to differ. And unfortunately, the way that you figure out who to listen to is based on their track record for being truthful. And that's the job of a journalist. And if you can't do that, if you don't trust journalism for whatever reason, your only other option is to read the research for yourself. And a lot of people are not equipped to do the research. So I think there should be spaces, there should be incentives for the public to care about the actual data where they can see the data for their own eyes, and not a chewed up summary by a science media person, which can be quite good, right? Like, I don't want to crap on science communication as a job, because maybe one day I want to do official science communication. I love communicating science to the public, but like, if you read the data, I think if you have it honestly explained, most people will come to a conclusion that is reasonable. Maybe not everybody agrees, but if you lay everything out, that's really the only way that, you know, outside of trust for the science institution, that people get that information, right? You told me to remind you that near the end of stream of what I said, even if this 110% proved that aspartame causes heart disease, I wouldn't care because everything seems to do so. Exactly. The mechanism that this paper found was that insulin spiking can lead to heart disease. And the fact that you're just eating causes heart disease. So, like, should you care based on this? I don't know yet, because we don't really have a good idea if aspartame is spiking your insulin harder than regular sugar in a regular human from this paper, because this does it in mice that are genetically modified. So I think it's very easy to be like, well, everything causes cancer, so I'm not going to care. And I think that is doing a disservice to the hard work that a lot of scientists are doing, and the disservice that this paper is doing, right? There's something genuinely interesting here. And that's why when I read a paper, I give the authors as much leeway as I can. But if they write in a way that is infuriating, I am less likely to give them as much grace. So the reason why I both agree with you, but I also want to warn you that if you shut off, if you get a little closed-minded with things that surround diseases, then you are kind of playing into a narrative, I think, of certain research not being important. And I'm not saying that you do, right, C.R. Smith? Like, if you're here, I believe you believe that science is important. But if you lose patience for the nuance that science demands, you can contribute to this cultural understanding that everything causes cancer, so who cares? I mean, we don't know if we should care yet. And over time, and science is slow, over time we will find out what you should and should not care about. Some opinions of doctors might be sus, but most people don't have the time and skill to dig through the data. Exactly saying. And so I want to provide a space here. I'm not a doctor, so I can't do that for your health, but I can do it for these papers that are adjacent to health, right? The papers that catch the news headlines, the papers that go, this happened in a mouse, and then people get afraid. And then what I can do, because my background is biology and not health, is I can explain the biology, and then I can make sure that you understand that biology is not health, is not equivalent to health. It's not one-to-one. It could be, but you should talk to a doctor about that, a doctor that you trust. Does protein affect insulin to spike? Aspartame is a protein dipeptide. So I think it's more about the circuit, the act of eating can do it. And so I don't know about metabolism, but it seems that at least the people who are talking about the paper agree on the idea that the sweetness receptor is involved. Although that schematic that I had shown earlier had shown that the act of eating can do it as well. Also, welcome, Pamela. Welcome to the stream. You're about the end where I'm burning out and talking about expert opinion and stuff. The natural food guy said some pretty sus things. I would say, I don't want to accuse of dishonesty or being paid by anybody, but I will say that seems like a shockingly strong opinion to hold based on the results of this paper, right? I'm very careful to word my disagreements as disagreements and not accusations, right? Because I don't know what the nutritional thing is. Like, I'm not going to assume that I know who they're funded by, Big Sugar or whatever. But I will say is that if we're looking at the same paper, we are reaching very different conclusions. And my audience, I believe you are probably closer to my opinion than the nutritional science guy. Okay, so what do I take away from this? So this is my conclusion. I think this was a lot of fun. I think it's going to be a great VOD. So this is my conclusion. In a background of cardiovascular disease, right, these mutant mice, insulin seems to affect this receptor, which affects macrophages, which could potentially lead to heart plaques. This is a very interesting target for heart disease. But anything before insulin here is just not that strong. So the thing that is concerning, the open question, the thing that makes the story complicated is that because this is the strongest connection, in my opinion, so anything that raises insulin could hypothetically lead to heart disease, like normal sugar. So I think it's up to future work to see if aspartame is uniquely powerful in its contribution to heart disease. And I think that, like, there is a future where we find out that if you have a genetic marker, like if you as a human have a mutation in your ApoE gene, then maybe you should lay off the aspartame. There is a future where that's true. And I want to be open-minded about that future, but I will believe it when I see the freaking data, right? Like, that is the attitude I want to impress upon my audience. Like, don't just negatively react to old, because this is how you get stuck, right? Science is all about paradigm shifting, right? Like, you know, we used to believe in miasma. People might argue that we're returning to miasma given the current state of biology research in the current administration. But the idea is that, you know, there could be a scientist with an opinion that is different than everybody else's that happens to be correct. And we should be open-minded to that fact, but we don't want to be taken in by grifters, right? So we should give them the attention. We should listen to them, But then we have to be very careful about what they're saying, and I feel like I did that here, right? Like, I don't have a personal horse in this race about aspartame in particular. I don't drink aspartame. I don't care. They write in a shady way that I don't agree with. But what I can say, giving them maximum credit, that the macrophage thing is super interesting, and I'm excited to see where that goes, and I hope they do a good job investigating that. The whole aspartame story, I kind of groan at, but yeah, those are my thoughts. And so, do I align with Reddit here? I align with Reddit that I am not happy with this paper. Do I align with Reddit about their criticisms? No, I think Reddit ignored all the things that needed criticism and then didn't give any praise to the actual good things. The takeaway is that macrophages may cause plaques, and that may be increased by high insulin. I would say that's a reasonable takeaway, asterisk, in a background of a mouse with a mutation that gives them heart disease. The way the paper is written is kind of too suggestive, but has some good information. Yeah, that's why there's some nuance here, right? Like, it's very easy to open a Reddit thing and then, oh, the science is paid by Big Sugar, blah, 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 and then they fight. But that's not an interesting story. It's more interesting to actually look at the thing and come up to your own conclusions. And while I have framed the data in my interpretation, I think I did a responsible job by showing you the data. I did not knowingly lie or omit things. Maybe I omitted things by accident, but I did not knowingly omit things. And when I suspected that I did omit something, I went back and I double checked, right? So I want to communicate that I am being as honest as I'm reasonably capable of doing, being one guy doing this in my free time. But I hope, chat, that was an interesting stream. I hope you got an insight as to how a scientist with a chip on their shoulder reads literature. So I will I'm getting very tired in terms of my voice, but I want to hear what your reaction to this stream was, like about the data, about me doing this format in the future. I don't foresee myself doing this very often because this is like a lightning in a bottle situation where I'm like, oh, this is a paper that Reddit is gonna hate for sure. And then like it's interesting to like look at the stuff downstream. Interesting seeing how the sausage is being made. Yeah, I liked it. I'd like to see it again if the occasion arises. Yeah, I don't think I would go looking for a paper like this. Although if you join the Discord, !Discord, you can certainly suggest papers for me to do. I think, like, because here's what I don't want to do. I don't want to be a debunking channel, right? Because what did I not do? I didn't use the language of debunking YouTubers. I'm not saying this paper is paid by Big Sugar. This paper, this is what's all that's wrong with this. Like, I think there exists a space between completely shilling for a paper and debunking it, right? I don't think I debunked anything here. What I think I did is I showed you the actual data and I talked about it. I did a freaking journal club. Yeah. It was really interesting. Yeah, the paper is surprisingly fine. It was not the train wreck as was depicted on elsewhere. Exactly. Reddit think this paper is terrible. It's got some sussy elements, but it's not terrible. Do I think it should be in Cell? I don't think it should be in Cell. That's just my personal opinion, but I think it deserves to be published. I liked it as well. Thank you. That's good. I was surprised to see the immune system pop up in here. I was in neurobiology, and why I picked that lab was because they had an immune focus. It seems like the immune system has its little grubby little dendrites, grubby little membranes in all body systems. It was quite fun. I liked the live stream. I'm glad to hear that. I enjoyed your teaching bits to fill gaps in knowledge. The gene removal stuff is cool. Yeah, I'm going to do a genetic engineering 101 where I focus on explaining everything from the ground up about all the cool ways that you can genetically engineer organisms. But since we can clearly see your DNA, your nucleus, are you about to go through mitosis? Oh, very, very good flex. Very good flex understanding the condensation of chromosomes leads to mitosis. But I've already gotten roasted for not having tripartite nuclei. Neutrophils actually have their DNA segmented into 3 separate distinct sections, and you don't know that's not true in the z-axis, right? Like into the screen, I could have 3 lobes and you just can't see them. Educational to teach me to understand data and read research papers. Like, I don't think that my stream should be a substitute for graduate school, right? Like, you should not walk away with my stream and thinking, oh, I'm now equipped to read a research paper. That's too much. I can't sell you on that idea in good faith. But what I can do is I can show you the depth, the nuance and the depth of what it takes to read a research paper. Because in order to get as rich of an experience out of a paper as I did, you have to go to graduate school or have some amount of post-bachelor training. And that's gatekeeping for a reason, right? I just need to gatekeep. You got to know biology to read a biology paper. But if you have the biology explained to you, then you can make your own conclusions. I think that's fair. Why do neutrophils have segmented nuclei? I don't know. I'm still learning about neutrophils myself. I don't know everything about my own identity, and maybe one day I will learn. I like, my favorite parts of graduate school was reading journal clubs, right? Like, I loved hearing my PI, my professor, tear apart a research paper, but the reason why I'm so cautious and the reason why I advocate for what can you pull out of this paper, don't just have a blanket angry reaction, is because my PI would say this all the time. What can you get out of the paper? She'd be like, I know the paper is bad, but what is the minimum unit of information that you can extract? And I think that was very wise, and it made me a little more humble, because as a graduate student, once you get the ability to start criticizing scientists, you kind of go mad with power. You're like, oh, I'm actually smart enough to be like, this experiment is bad, and it can go to your head. You can get a big head about it. But she kept me humble by being like, not all experiments, you won't have the perfect setup just practically in all situations. And I think that was I respect that kind of mentoring a lot. And in a way, a lot of my journal clubs are homages to my PI, because I am trying, and I hope I'm doing a good job of providing the mentoring she gave me onto all of you. Are all neutrophils as cute as you? I have in terms of acknowledging bias, of course, I have a particular point of view. Not sure if I missed it, but we discussed the vagotomy part. I think I probably skipped that part because I didn't find it necessary to tell in this story, although I could be convinced otherwise. I don't mean it that way, just how reading a paper all over works, not just cutting some portion, highlighting. Yeah, exactly. Like, I mean, let's be real. I didn't show everything in the paper. I cut out a whole section, but in terms of like, how does someone with graduate level knowledge dissect a paper? How does one person, right? Because I'm not every graduate student, other people will do it differently, but that is an example. So you can get an idea of like what goes through the brain of an academic evaluating the legitimacy of a paper. So yeah. Why do macrophages cause plaques in general? Why are they doing that? Aren't they? What are M1 macrophages? So macrophages come in different flavors, and M1 macrophages are of the pro-inflammatory kind. So they are a subtype of macrophages that do pro-inflammatory signaling. I'm not enough of an immune person by training to know exactly what they're up to. But in terms of like my own study of the immune system, I'm just like, immune system probably does it. You know, like, immune system probably makes it worse, probably makes it better somehow, because inflammation is so intimately connected with all body systems. And we don't know the mechanism by which the macrophages are causing the plaques. We just know that they need that receptor for aspartame to hurt the heart. And the details on that are not yet known. And maybe one of you currently in the audience are going to be the one to find out how that happens. And that would be very interesting to note. I think that would be cool. Okay, it's been 3 hours. I loved doing this stream, by the way. I think it's so fun to show you all, a little bit how the juice is made, and how the sugar-free juice is made. Let's see if I know anybody currently streaming, and if there is anybody currently streaming, I would like to potentially raid them. So let's go ahead and let's maybe check Twitch as well, because half of vtheorem is on Twitch. So let's see if Twitch is streaming. It looks like we actually do have NEP streaming. So I will redirect everybody to NEP's stream. So that's a little difficult because NEP is on Twitch. So let's see if I can do that real quick. So I'm going to link Nep's Twitch right now. What are they doing? They're talking about houseplant health. That is what they are streaming. So let me go ahead and paste that link in the description. Go to Nep, Myelin Sleep. Yeah, that makes sense. So that is where Nep is going to be. And let me go ahead and post the raid message if you want to help me raid into Nep. Stream Elements bot. Stream Elements bot. There we go. So let's go ahead and we can copy and paste that message. And if you want to come hang out with me in Nep's chat for a bit, I'm going to actually probably go to bed shortly. But if you want to hear about how to take up your the health aspects of your houseplant, we can definitely go there and to find out what that's all about. Yeah, I loved having you all here. Thank you for attending. Bye, y'all. Goodbye. Bye-bye. Bye-bye.